Hi, everyone. My name is Chris Knoll. So we'll be going over cohort definition and phenotyping. We'll be doing it with Atlas will be one of the tools we study today, and we'll also be using Aphrodite for our probability-based phenotyping. My name is Chris Knoll. I work for Janssen R&D. Other faculty in the room, if you could raise your hand, we've got Juan and Joel. They will be here presenting their own material as well, but also to help out with any of the questions that we have in our class. So for disclosures, I am an employee of Janssen Research and Development and shareholders of Johnson & Johnson. The paper that we're dissecting today actually has a J&J product and J&J competitor's product. We will not be talking about the merits of one drug over another. We will not be going into the results of that paper. We're going to be focusing on how to define the populations that were used in the paper and those type of issues there. Okay, but I will not be commenting on any of the actual results of that paper. Here's our agenda. Just getting a little late start with the introductions, but we'll be doing an hour overview, and then we'll be moving on to a 30-minute student activity where we dissect our paper. Just to ask again, everybody got the homework in the paper talking about the anticoagulants and that paper? Okay. We will be, then from 10:30 to 12, we'll be doing the Atlas kind of walkthrough and instructions. We'll have an hour break for lunch. After lunch, we'll do probabilistic phenotyping, talking about the same types of populations that we saw in the paper, but using Aphrodite and probabilistic phenotyping. And then Joel will present information on how to evaluate phenotypes and cohort definitions. Then we'll have an hour and a half in the afternoon, so think about this. We'll be polling the group to ask about a particular type of question that we want to try to represent and ask and answer using OHDSI tools. And we'll spend an hour and a half on that. It'll be a good opportunity for you guys to really use the tools hands-on, figure out if there's any confusing elements of it that you'd like to have some questions answered. We'll be here to do through that. And then we'll talk about, based on how we do in that session, I'll pull up some topics about what I consider advanced techniques in Atlas so that we can maybe solve some of the problems that you thought couldn't be solved. We'll talk about advanced Atlas techniques. And then finally, we'll finish up on talking about applications of cohorts, as in you've done all this work to define your study populations, but how do you actually answer a question using the OHDSI tool stack? And that will take us through the end of the day. So before we get started, let's just settle on how we're going to log into RStudio. If you guys want to do direct queries on the database, you'll be able to do that. So just go ahead and count off 1, 2, 3, and just write down your number, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, Joel, you're 12, 1, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. All right? And to log into RStudio, it'll be user, your number, and then password 1. And if you want to try that now, that's fine, but we're not going to be doing this. We'll have a break to just get that all situated. So I'm going to, yes? Absolutely. I think I put it, where did I put it? Yeah, okay. All right. So what I'm going to start talking with is just the general principles and cohort definitions and what is it, just to get some of the vocabulary and terminology in place so that we can talk about what is a cohort, how is it used, why do you use it. So the paper you all were asked to read was to evaluate the risks and benefits of direct oral anticoagulants versus warfarin in a real-world setting. So when you look at this paper, one of the questions you might ask is how can we use OMOP common data model to perform this study, and like what does it take? Like what do you have to do to do this? To understand and answer that question, we have to look at, well, what is the paper actually producing as far as like what questions are it answering? So we have, there's one element of the study that's trying to do a comparative effect using hazard ratios between one treatment and one comparator, in this case warfarin and DABI, and the outcome being major bleeding. And so they report on that. They also maybe will do a characterization of the cohort to talk about like what year did their treatment start. They might get other information, demographics reports on what their age groups were. They might have comorbidities reports based on the cohorts in question and what their comorbidities at baseline. So these are four kind of different questions that was asked about the disease natural history, the characterization and demographics of the cohort, what was the relative risk of taking one or another drug for a certain outcome. So OHDSI's position is the common building blocks of performing these studies are the cohorts and how you define these cohorts. If you want to do characterization, so baseline summary of a treatment for treatment utilization, then you need what we call a target cohort, and that's just the group of people that satisfy the criteria. You might want to compare that cohort to another cohort, so that's another cohort of a study population. You might want to look for some natural disease history of the cohorts that you are using as your outcome. So again, it's another characterization exercise of a group of people that satisfy the criteria of who has this outcome. To bring these cohorts together, you might have an incidence calculations, or you want an incidence summary of what is the incidence proportion or incidence rate of people within the target and comparator cohorts among with the outcome of the members of this outcome cohort. You might want to do a population level effect estimation where you take a T and a target cohort and a comparator cohort, you balance them in some mechanism so that they are comparable, look for the outcome, and then calculate the relative risk, either hazard ratio, odds ratio, incidence rate ratio. And also, questions supported by OHDSI are predictive problems, where you have a target cohort with a certain amount of follow-up time, and you'd like to know if you can predict the likelihood of an outcome within 180 days, a year, something like that. So all these problems involve starting with the cohorts. So the definition of a cohort is a set of persons who satisfy one or more inclusion criteria, which we call the phenotype, for a duration of time. The important difference between a phenotype and a cohort definition, or a cohort, is that the element of time. It's one thing to say that we have a case. There's another thing to say that this person was a case for this period of time. So we're going to be talking about phenotypes as a way of identifying the time that a person satisfied the criteria for a cohort, but the cohort itself will be the moment, the time durations of when a person satisfied that phenotype. So some things to know about cohorts is that a person may belong to multiple cohorts. It's just not an exclusive thing. You can have membership in multiple cohorts. A person may be a member of a cohort at different moments in time, so they can, in the course of 5 years, they may have 1 year of being present, another year of not being present, and then presence again. One person may not belong to the same cohort multiple times during the same period of time. This is a little bit hard to possibly imagine, but if you think of as a cohort as, if you think of a cohort as like entering a room, you can't enter the room after you're in the room. So from a data representation perspective, you don't say that if you're saying you're in it for the first half of the year, you don't have another record saying, oh, and I entered the first quarter of the year. It's logically does not make sense. So cohorts are really about continuous times, no overlap. A cohort could be an empty cohort. The cohort of unicorns is empty, right? We can describe it, like where's the horses with horns, but you could have nothing that matches that phenotype in reality. And finally, a code set is not a cohort. You see a lot of papers that describe, we define the cohort as these codes, but that is half of the statement about the cohort. It's about the setting of the code, the proximity of one code to another code, like the diagnosis that followed a test that had a subsequent surgery. All these things actually are what defines the phenotype, not just a code. Although I will say, for simplicity's sake, you could just say, if you have this code, if you have the diabetes code, then you're diabetic. So, defining a phenotype. What is the phenotype? George Ripsack has a very good article talking about phenotyping and cohort definitions. This one is more about promoting more of a model building approach to phenotyping, that the more information that you can collect and apply to your cohort definition, the more robust a cohort definition will serve you. And so, some information out of this article was a phenotype is a specification of an observable, potentially changing state of an organism. This is very important. If you have a disease, an acute disease, the status that you have, the phenotype of whether you have that quality of having the disease may change over time. So very important information, knowing that a phenotype is something that can change is very important. The term phenotype can also be applied to patient characteristics and data. So all the data that you have in a medical record can be used to qualify something as being part of a phenotype. And then finally, phenotype algorithms can may be generated by domain experts, meaning the domain expert is the arbiter of what makes a certain person a certain phenotype, meaning rules. They have their rules, and if the subject matter expert defines what those rules are, you apply it to your data, and you find the people that satisfy that. But also, there is machine learning algorithms that can go in that if someone can tell you, these are what people that I think are have this phenotype, machine learning can go on and analyze all the data and create a predictive model that can identify those people in data without you having to have this real complicated set of rules. So there is a space out there for probabilistic phenotyping as well. So just to reiterate that, the two types of phenotyping we'll be talking about today is rule-based phenotyping and probabilistic phenotyping. Behind both of those, Joel will be talking about phenotype evaluation. So as you tweak your rules for your rule-based phenotyping, you might want to know what kind of effect that has on sensitivity and specificity in the population. Same thing with probabilistic phenotyping. There are various settings and dials that you can turn on that, and you want to be able to evaluate how the results of your cohort and your phenotyping exercise, how is it materially different? How do we evaluate that between one result and the next? So just to give a little picture of how cohort definitions and phenotyping kind of come together, what I have on this diagram here is basically a timeline for a single person, and the top side of this timeline is what a probabilistic model might show for every moment in this patient timeline about them satisfying a phenotype. And as you can see here, it goes from 0, and as time goes on, the probability that this person falls into a phenotype goes up, and then it goes down. This is representing that change in the phenotype characteristics over time. With probabilistic phenotyping, it becomes like a curve, like the probability goes up and down and sways over time. With rule-based phenotyping, it's more of at a moment, you either are or are not, and it goes from yes to no, yes to no. So when we talk about phenotyping with rule-based, we're really talking about categorizing it as yes, no, whereas phenotyping with probabilistic phenotyping is more of about 50% likely, 75% likely, 95% likely. In both of these cases, when we talk about, what is their presence in the cohort, probabilistically, you would maybe draw a line across the whole data set and say, as long as they're above this threshold, they are in the cohort. So in this example, where I say it's around 80.8, the time that they're in the cohort is represented by these two separate intervals. That was the time that they were probably in the cohort. If I lower it, suddenly I get a wider range of the cohort periods, and I also picked up the second period being in the cohort because we lowered the threshold. Does that make sense? So again, cohort definitions, the essence of it is when they start and when they leave and if they can come back. In the case of the lower picture here, they are in the cohort right here. So during the timeline that they are in it, and it's pretty, straightforward. It's the only way to change this is if you change your rules in some way to allow them to be in it longer or add more criteria. Yes.
Is there a general convention about what threshold for probabilistic?
Well, Juan will go into that, but I would say no. It would depend on you set your threshold, you investigate the profiles that the model predicted for you, and you decide is that should we be more strict or should we allow like a lower threshold kind of thing. You just kind of evaluate it, but I would say with the characterization tool you can set a lower threshold and a higher threshold. You can look at the difference between the characteristics and say like you definitely will get more people if you lower the threshold, but is it too loose? You just have to do the evaluation for yourself. But there is no rule of thumb. It's basically what you want to live with in your study design. Okay, so to build these phenotypes, you need your data. The common data model has various domains of data. Examples of those domains: conditions, drugs, procedures, measurements. There's this article out of AMIA that kind of did, and it'll be in the slides, you can look it up and read this one. But they basically call out that different elements of data will be more useful for targeting different disease areas. So it's hard to read on this one, but they talk about MI would be like HbA1c would be better with lab tests with like glucose levels and things like that, whereas depression might be something that you have to get from notes. So the point here is that you leverage, the more data you can leverage on your phenotyping, the better and more robust it can be to isolate the type of population you're trying to build. So here is a picture of the common OMOP data model. I'm not going to get into too much detail, but the point here is that each table for each domain there's a table that will store specific fields for say drugs. You might have dosage strength. For measurements, you have values. For conditions, you have the diagnosis code, etc. Many of these things are associated back to a visit, so you're able to look at the setting that the observation was made in. So these tables in the blue are about like the patient record. The tables on the other side here are our standard vocabulary. Has anybody in here? Are you guys familiar with the OMOP vocabulary? How many here? Raise your hand if you are familiar with the OMOP vocabulary. No? Okay. So the purpose of the OMOP vocabulary is to provide mappings between a coding system that might come from a source system to a standard coding system that we want to use in our analysis. For example, there is a code for diabetes in ICD-9 and ICD-10 and SNOMED. So we want to avoid having people have to record, if you're diabetic, you have this ICD-9 or this ICD-10 or this SNOMED and all the other type of coding systems that could exist. With the standard concepts, you can map ICD-9s to the standard concept, and then you create your phenotype off of looking for the standard codes. These tables have ways of very easily navigating through the vocabulary and finding what more specific classes can roll up to more general terms. So you might have many different variations of psoriasis. So there is a psoriasis concept, and its descendants are plaque psoriasis and all the other types of psoriasis that you could find in medical literature. So, not that we're going to study the OMOP vocabulary, that's a totally separate class, but these are the tables just to get yourself familiar. When we go into Atlas and cohort definitions, you'll be able to create criteria for each of these type of domains. So if you're looking for a procedure, there's a procedure criteria. If you're looking for drug exposures, there is a drug criteria. Okay, so getting a little technical now, I just wanted to walk through an exercise of how you could use SQL to create your own cohort without tools. This is how research is done. They have a data set, they have a SQL database, they can write SQL queries, and they have to create their cohort definition. So what we're going to try to do is we're going to try to find a cohort of acute MI. And hopefully you guys can see this okay. This is also in the lecture folder of one of the queries. But let's just walk through this, and if we want to get into deeper, we can actually analyze this further. But the start of it is I'm going to query the condition occurrence table for the code for the standard concept of acute MI. And what I'm going to do is I'm going to use the concept ancestor table. Has anybody heard of the concept ancestor table in the CDM vocabulary? Okay, that table, just to refresh, is to basically say you can start with a higher level term of acute MI, and I could get all the descendants of acute MI, such as if they're talking about the area of the body and the heart and various other subclasses of acute MI. So all I'm going to do here is I'm just going to query the person, the condition start date, and the condition end date. That's the elements of a cohort, person, start, and end. And I'm going to select that from the condition occurrence table, and I'm going to look for everything that's related to MI according to our standard vocabulary. And what I'm doing at the end here is I'm just going to select the top 10 events from that query and just see how it looks. Does it really give me like a cohort? Is this truly a cohort? Okay. So I get this result set. In the top 10 events, I have I have two people, person 7 and person 9. This actually came from the 2.3 mil SimPuff data set, in case you're wondering. And as we see here, there are diagnosis codes that happened on the same day. And so we have this October 9th and to October 10th. It's person 7 got diagnosed there. So we have a situation here where a period of time of one day overlapped with a period of time on the same day for the same person. That violates the cohort definition rule. So those records, this is no good. This is not okay. So you can't that is not going to give you a cohort. Okay? Everybody pretty clear on that idea? So why don't we do a select distinct on the table? So I added a select distinct. So now we're definitely going to just get rid of all those like duplicates. So that's cool. So I do this query here, and it looks like that I have now eliminated those duplicates, and maybe this is a good cohort result. Now, did I really fix the problem? The only way to know is if I write a query that basically says, from that result, do I find anybody that has overlapping periods of time? And that's what this complicated query does. We don't have to analyze this, but basically I'm going to take those results, every person, line up their own record, and see if there's any overlaps. And in fact, I found cases where there was this person that had from May to the 19th, they conflicted with the 19th to the 22nd. So that was, I'm calling, if they share the end date, that's going to be overlap. And you can see, you can just look through here and you can see that there's these periods of time that they overlap. So that did not work. We did not solve the problem by just going with distinct. So instead, what I'm going to do here is I'm going to select the first record per person. So it's only going to select one record per person, and going that route, they will not have, one person can't conflict with itself because there's only going to be one record per person. So when I select the first record per person, I do my little conflict check, no records. We are good. This query will be this could be used, the result of that query is a cohort. One person, no overlapping time. So that's a very basic cohort query, but we might want to do additional things, such as I want to make sure that the records that I find have a certain amount of continuous observation before the event. Does anybody have any questions about what I mean by continuous observation? Is that an obvious term, or does everybody know what continuous observation is in the OMA Common Data Model? Yes, what? No? Okay. So a continuous observation means that if you take an observation period and you find the moment in time within an observation period, the continuous observation is from that moment back to that observation period's start date. To put it another way, observation periods are used to establish when you're asserting that you have no gaps in observation of a given person between the observation period start date and the observation period end date. In healthcare claims data, an observation period may be defined by their enrollment in a plan, because the assumption is that if you're going to the doctor or going to receive medication, you're going to go through your plan. So as long as you're on the plan, we're going to say that we know what type of medical interactions you're having. Is that guaranteed? Could you go to someplace else? No. But observation periods are just a statement in the data of saying, this is the assumption that when you go between an observation period, start date and end date, that there's no lapses in observation. Like, we're going to assert that if there's something happening to the person, you will find it within this data. So think of another context, though, like where while you're in the hospital, you're under observation, and you're only in the hospital for a day or two. Observation periods in a hospital setting might look like very short. One person might have 2 days, and then a month later, come back, he has 2 more days. It's hard to do a longitudinal study with that type of data because there's all this unknown time between one observation and the next observation. So, how does that work for you?
So it works, except I have one other question.
Sure.
When you're talking about an observation period, can you say an observation period with a certain condition?
Yes.
So basically how you define it is as long as it is continuous, whether it is conditional.
Right. So when you create your CDM and you have your data, you have to establish like what is the rule of continuous observation for this data set, and it varies from one system to the next. But you always use observation periods to establish what is the continuous observation for a given patient. Why do you need that? It's the difference of saying, if I just met you and I want to know, and you have a problem and I just met you, I don't know if you just developed the problem or if this was something that has been going on, like this is not something new. The only way for me to say, oh, this is something new, is if I actually knew you for the given 6-month period or the year prior. So when using observation periods, you're basically saying, how long do I know this person? And by using that information, I can say, did they really just start taking this drug, or did they just have this new outcome? Or is it something that they've had they've always had? Without saying the observation period, we can't actually assert that this is something new.
I just wonder how much this is related to the condition per se as well, not only the data, because there are algorithms developed using claims.
Yep.
And many times the continuous observation is not defined within the same time frame depending on the condition. Is that a factor that will be defined?
It would be a factor in how the system. I will say that from a common data model perspective, they don't have that. You establish each person has their set of continuous observation periods, and it's not based on a condition. It's not based on a context. It's just, for this person, we are asserting that we know about them for this period of time. So I understand what you're asking about with algorithms being used and maybe adjusting the observation period based on some, yes, that is something that is interesting, but for purposes of CDM, it's just each person has their observation periods that is asserting that this is known. If it's happening in this period, we know about it. And if you want to say, I want to make sure they have the absence of a condition in the observation period, if you don't find it, then you can be sure that at least you are assuming that in this observation period, that's fine. If we have breaks in an observation period, and I said, I want to assert that something didn't happen in 10 years to this person, but their continuous observation only goes back a year, and then a gap, we can't say for sure that it didn't happen to them because there's a gap in our observation of it. So observation periods is a very important concept in CDM world, even though it kind of is in this background, sort of like it's behind the scenes. But I'm spending a lot of time talking about observation periods. But it is a construct that we should all be aware of because we're going to be using that construct when we create our new user cohorts, for example. So, point getting back to the SQL is that the query for the SQL suddenly got a little bit more complicated when I wanted to introduce the idea of continuous observation. I had to add a join to the observation period table for the person, and I had to make sure that the event for this person, for the AMI, had the required amount of prior observation that existed. So the first thing we did here is we joined to the observation period, and then I looked to see that there was at more than 365 days. I said a year, and I wanted to see each record has to have 1 year of continuous observation. The logic behind that is to say that the start date of my observation period was longer than 365 days ago. That is the logic behind continuous observation, okay? Yeah?
I would like to go back to the observation period part. So how does hospital define this continuous observation period?
How does who?
Hospital?
Oh, a hospital? If you have, it depends. Like a hospital could, when the person ETLs an EHR record out of the hospital, they could be looser with their observation period and say, this person always comes to the hospital and we'll let you start. The first time we know of you, we'll just know of you until we don't know of you anymore, or even current date. Or if there's some reason that we know that you're no longer going to come to the hospital, right? But what I've seen in hospital settings is that they're very discrete periods of observation. Like while you're in the hospital, you're under that observation period. And doing longitudinal studies is kind of hard. But if you wanted to do a type of study that happened, what happened when they entered a surgery and the 4 days of follow-up? You could find people in a hospital setting that had that situation where they received the surgery and they had at least 4 days of follow-up. And then you could look for things like infection or readmittance or something like that. You could also do a readmittance type of study by basically finding all the people that first entered a hospital. You could do that. And then you could look for what was the readmission. Like, did they have a readmission rate? And that at that point, it's not about continuous observation. At that point, it's just, does the presence of the data exist?
Another question is, so if we want to merge two data sets,
Mm-hmm.
say, okay, if we want to do analysis in a combined data set, how should we deal with this observation period?
From my training, you don't merge. You have two different data sets and you perform the analysis separately and maybe do a meta-analysis, but you just don't merge data sets. Okay? Yes?
I was going to suggest that sometimes you do merge. You
Okay.
have to merge data sets from multiple hospitals. What we've done in CTRM, we just took the first available observation and the last available observation for each patient.
Sure.
That was their
Right. I mean, I think there are insurance companies that will aggregate claims across multiple providers, and then from our perspective, it doesn't look like a merged data set, but it very well could be a merged data set. But if Patrick was here, he's like, don't merge data sets. And I think that's just a safe answer. But you're saying that you can, and it has happened, and you do it. Like I said, I wish I could be more constructive with I have the answer for you. I think Rima probably has far more experience on that particular topic.
And again, much more experienced people have gone into the effort of trying to identify with algorithms the continuous observation period, and we've come to the conclusion that the safest way to do that when you're dealing with multiple data sets aggregated is to look at the continuum and the entire continuum of patient care that's available.
Okay, thank you.
So when you talk about multiple data sets, you talk about EMRs?
Yes,
Yes, only.
we dealt with EMRs.
Okay, because I was thinking whenever, when we link, how good is to have EMRs with claims?
Pardon?
We're talking about EMRs data, EHRs, right? We don't talk about linking with claims, for instance.
Right, well,
Like when you link with claims, you actually get richer information maybe. But
Well, when it comes to claims, there's some language in a license of claims that you cannot link.
well,
So there's restrictions in that way. So again, it's so what I'm caught in the middle of is sometimes it's governance that prevents that from happening. Sometimes you can do it because it makes sense. You have individual offices, and they have their individual data sets, and they all are under a same program. So in that case, those are separate data sets that you can merge, because you can go into any of these offices, like you're allowed as part of the program. You can go into any of the offices, and we're all networked together, like a Premier or something like that. So that's why the struggle of answering it depends on the nature of the data, what you're allowed to do with it, and if you can do it reliably. And
As
if
a
you,
rule, you wouldn't, though. I mean, as a rule,
I feel like, the reason why you would say that is, the way I would say that is because it's just safer to treat data collection for one purpose together. And if you had, if you wanted to augment your data set by merging in a cancer registry, I just don't know if that's really appropriate. To basically say, I have this cancer registry and I have my claims, why don't I just start learning about cancer? I don't know, you would say you can?
We will.
All right, but I think it takes work, and you have to be diligent about making those records added. You can't just do. I feel like it's probably a very deep and considerate conversation that has to be had about what makes that possible.
It really depends on the type of data you have. If you have identifiers, you can find the patient and the data set and merge them together. But
Right.
the secondary data that we get, we don't have identifiers. So it's better not to merge them. Especially with the claims. If you want to merge two claims, you don't know whether a patient was in other databases or not. Maybe. So it's safer to not merge the identified data. If you have identifiers, yeah, we can.
Yeah,
If
exactly.
you can match them. Sometimes you have names and some sort of identifiers and we cannot.
Yeah, yep. So, for our talk today, it'll be data agnostic. It'll be about what data exists and what can you leverage to define your populations. So, but this is very important questions though that you want to consider when doing when you're doing your study on this OMA common data model, but probably on any data source at all that you want to use. Yeah, go ahead.
so then is when you have an entry in the continuous observation, are you basically claiming that you're omniscient during that period of time?
That's exactly that's a way of putting it. If you're in this observation period, we are making the assumption that if something happens to you, we will know about it. And if something, you gotta draw the line somewhere, right?
Crazy, but it's not.
Yeah, I mean, yeah, it can sound crazy. This is where big data though kind of helps though. Even things that you might not know happened or you could not observe, there are other things that you do observe that may have a correlation to it. And these machine learning algorithms and propensity score matchings, using all the data that you possibly can, covers that gaps and suddenly makes it not quite as crazy as it sounds. For example, Mark Suchard talked yesterday about how they didn't have stolic pressure or some type of measurement in the data for a certain type of condition. But what they did to validate, do we need that lab value, is they built their model based on all the other covariates that they had, and then looked at the people that did have the measurement in both groups and found that the variance of the measurement from one group to the other was kind of in line with what they would have looked for as far as saying like you have to have this stolic measure, the actual measurement. So the point is that with enough data and enough statistics, these unobserved confounders and these unobserved influences that come that you're right saying like I have to know everything. Actually, it's probably the case that if you have enough collection of data, that there's enough correlation between certain events that you actually can infer more than you think, just using machine learning techniques and just large scale analytic processing. So, but that being said, it is absolutely the case that saying that you are omniscient during this period of time, it sounds godly, but all you're basically saying is that we are willing to accept that if we don't find the record here, then it probably didn't happen. That's what the observation periods are about. Okay, so this is just to extend the query, adding a join, doing some mathematics to figure out do we have enough continuous observation before the event. Next, I want to say, okay, but I want a certain gender or sex in the population. So that is another join to the person table looking for a certain concept ID. So I've started with just the condition occurrence, joined to observation period to get my continuous observation, joined to the person table to understand age or demographics. And then as a more complicated step, we're saying like we want to make sure you had essential hypertension sometime in the prior 6 months. So that's this large chunk of that's leading to another query saying, okay, I'm going to query the condition occurrence table again, but this time I'm going to look for that person that there was a different code in the last 183 days, and that they had to have essential hypertension. So that's this, this query is starting to get complicated and bigger, right? And so I did this, and I got, out of my 2.3 million people, I got 8,600 something people. And I might have a certain target, like I'm trying to do a certain size study for a certain amount of power, and I just wrote this query, and it's very complicated, right? But like, I don't know what happened. Like, I had 2.3 million. I thought like there was a lot of people with acute MI, and so what I'd have to do then is start pulling apart. Is it the continuous observation requirement? Is it not, like it's just a gender bias in the data, so I didn't find the gender that I wanted? Is essential hypertension just not prevalent in this population? Like, I don't know what happened, but I have so few people. And when doing your cohort definitions, you're going to want visibility into how your inclusions are impacting your final selection. So this is just a leading question that we'll come back to later about, like, we have this answer, but it doesn't. We might need to know, or would like to understand how my cohort definition resulted in this number. So things that we've kind of, just to review here, things we talked about: continuous observation. We have the notion of an inclusion rule. We could have the notion of an exclusion rule. And we've talked about just a couple of the domains of data, person and condition occurrence, that we use to define this population. Okay? For OMOP cohort definitions, instead of asking people to learn how to write SQL, because that SQL could be written in many different ways. If you have creative developers, they can tell you that there's a cooler way to do what just did here, and they want to show off. But that is harder to understand and harder to recognize what was their philosophy about building their cohorts. So what we want to do is, we're calling it, this is kind of like that omniscient statement about, wow, that's awfully presumptuous, right? But we're trying to develop a tool to standardize cohort definition, meaning when you look at a cohort definition, you can see the philosophy and the ideas that went behind constructing the population, getting them, defining their time periods, and when they're in the cohort, what will cause them to leave the cohort, that kind of thing. So this UI right here is just a shell of what Atlas will give you to create your cohort definition. The elements of this, let's see if I can, The elements of this is, first we want to identify those events that will get you into the cohort, that will enter the cohort. And those are potentials, because we could further qualify those events to maybe, you could have, but because you didn't match these additional rules, you actually didn't really make it. So the cohort entry events here is a way of selecting candidates for entering the cohort. And then at this point, you can specify, the continuous observation requirements that are required and which domains of data you want to use. Once you have that potential, those candidates of you're at the door ready to get into the room, this inclusion criteria acts as a sort of like a bouncer. And he will check all your medical history to make sure that you really should be here. And if you pass that inclusion criteria, then congratulations, you have now established presence in the cohort. You satisfy the phenotype. But then that's only half of the cohort presence question. It's not just about when you entered, it's also about when you leave, or can you leave? That's a statement that you probably will not find too often in journals, but maybe you will. But the point is that you've now established that you belong, but then what keeps you belonging, or what can disqualify you from entering, or from being present? So there's an element of standardized cohort definitions called cohort exit. And in this, you have choices of saying, one, you could say you're in for the duration of your continuous observation, which we talked about, but post-continuous observation. You're in it from that moment to the observation period end date that event belongs to. So that's one option of doing it. Other options of doing it is you can do a fixed offset, like from the event start time or the event end time, you can add a number of days to that time. And that would, say 60 days. Or if, let's say you got the flu, and flu on average lasts 10 days. Like you're under the effect of a flu for 10 days. So find your influenza diagnoses and just add 10 days to it. And that's the period of time that you're suffering from influenza. That's another option of cohort exiting. The final option of cohort exiting is another continuous word, continuous exposure. And continuous exposure means that you're going to take the moment of the event, you're going to give it a list of drugs, and you're going to find all the events of that drug happening in your patient history and create continuous exposure periods of time. And your presence in the cohort will start at the event and end at the end of that continuous exposure. This is going to be reserved for a more advanced later on in the day, but I just want to give you the three options. One option is you enter the cohort and never leave. You leave at your observation period end. You end after a fixed duration, or you end after assembling drug exposures into what's called the continuous exposure. So those are your three options of establishing presence and then continuing your presence. Now, as we saw earlier when I did the queries, we saw that records were built and they had overlapping time intervals. So what this tool will also do is say, if once you've established when you entered and how long you should stay, but another piece of record comes in saying, like, you entered again, we don't want to record that you entered again. We want to record that you continued being here. So what we have is the last element of cohort definition is the cohort eras. So after all the individual episodes that you've identified off of an event and an exit, those may lead to overlapping times with each other. Or there may lead to non-overlapping times, but like a one-day gap. And did you really want to leave them as two separate things, or did you want to kind of allow them to come together and combine into one continuous thing? So the last element of the cohort definition allows you to specify, after you've reduced all the overlapping time to continuous periods, can you then say, well, actually, if there's a gap within a certain size, an allowable gap size, then you can actually take those two different ones and bring them together and make them one. So you can do that with cohort, with the last element of the cohort era part of the cohort definition. Okay? So to review, entry, cohort entry, inclusion criteria to qualify that. How long are you, after you're qualified, how long with cohort exit criteria? And then finally, if you have different eras, how do you want to link them together? How do you allow those to combine? Yeah.
I think I'm a little bit confused about the days after index date, the first part there. So
These two right here, just to be clear. Yep. Mm-hmm.
So say you have somebody who has a stroke, and that's your total. You want to know patients who have a stroke. How do you define the days after the index date? So they have to be alive at least 5 days?
So that's
how do you work out the number of days after is what I'm asking.
So it's a good question. So what I'm hearing is, if you specify, let me unpack that a little bit. So the fact that they had their stroke, did you say? The fact that they had it means they're in the cohort. And if you said that they will stay in the cohort until their end of our observation period, for some person that'll be 7 days, and for other people that may be 2 years. If you want to enforce that they had to exist for at least 30 days, then you would specify this value right here saying, after that event, they have to have a year of follow-up. That's what this would do. Would that be appropriate for the use of the cohort that you want? Is your question, what? I guess to answer it first would be to say, if you specify a number of days here for the post-continuous observation, you are saying that they lived or they existed in the data for that number of time. And if they didn't, then they don't qualify for the cohort and you're not going to want them.
But you wouldn't want to do that, though, would you?
It depends. You wouldn't want to do that if you were trying to study mortality. And if you only picked people that survived 5 years, you're not going to find mortality because they survived 5 years. So that would be an immortal time bias in your definition. So for studies where you're studying mortality or adverse events and things like that, absolutely, you would not want to require post-observation time, right? But your next question probably is, well, when would you want to? When you would want to is if you're doing a prediction study and you want to be able to learn a model from people that did survive 3 years. And you want to know what are the characteristics of the people that once they had abdominal pain and they came into the emergency room, what is their likelihood that they had endometriosis or something? And so you want to find people that had the 3 years so you could learn something. If you allowed everybody to kind of just drop off immediately, you won't learn anything. So depending on the type of question you have, you will say, we don't want to put this immortal time bias, so post-observation, they don't actually have to have any post-observation. And that would be the type of study where we want to look at adverse events or mortality. But other times we have prediction problems, and we actually do want to limit it to the people that actually will give me information. So you look for post-observation so you can have that. And that's what it is. Right? Yeah, a lot of... I guess as a side thought, so when I was preparing these notes, I imagined that there would be a lot of questions and stuff about like the right and the wrong of things. And I guess one thing I want to just state to you guys is right and wrong, such as the observation time and being omniscient. Is that right or is that wrong? It's just what we're talking about here is just what we're asserting to do, and then the researcher can evaluate if it was appropriate or not, or for your purposes of your study, is that appropriate to make that distinction? Some things are very obvious that if you're trying to look for mortality, requiring 2 years of post-observation is not the appropriate thing. So you just do that. And so there are cases where it isn't, but there's not a general rule that you would never do that. Just like merging of the data in data sets. Sometimes it would not be appropriate if you can't link the people properly. But other times, as Rima said, it's totally appropriate, and it's actually how they do business, you know? So that's just a little soapbox there, sorry. I'm just trying to make sure that if you guys feel like that doesn't feel right, it's possible that from a certain perspective, it actually is possibly appropriate. And you have to recognize when the appropriateness of certain things are. Okay? Da, da, da. Hey, Gautam's here. Okay. So I'm going to just do this little animation to talk about those elements that I talked about just now, where we had the cohort entry and the cohort exit. So this is a timeline. It has the observation period described here in the 2 endpoints. And we're going to have elements of the inclusion criteria logic and what events we're looking for. So the first thing we start for is that cohort entry event. And we had some record that we're going to look for in a condition, a drug exposure, whatever the domain of data is. We look for that, and this is saying we found it. We found a candidate. Things you can do with those inclusion criteria is you can look for, within the prior time period, or any time period actually, depending on what would be appropriate for your use, you can say, I need to see, an inclusion means like I want to know that there was the existence of some observation in a certain time period. So in this case, we're looking prior to the start date of the cohort entry, we're looking for something had to exist. So an inclusion criteria would mean like we found at least one of an observation of some criteria. Okay? That's what we would say is that's the inclusion rule. Conversely, exclusion rules, which you've seen in journals and papers, they talk about exclusion rules. In Atlas terms, we don't separate inclusions from exclusions. Okay? They're all inclusions. But if you want to exclude something, it means you found none of whatever it is that you're saying. So if you're trying to exclude people with kidney disease, you're basically saying no kidney disease. Like I found no kidney disease. I am including people with 0 kidney disease. So what this second picture is showing is that's how you do an exclusion rule. You don't say exclude kidney disease. You say include no kidney disease. You have to have no kidney disease. Very important. I keep, I'm hammering this point, but this will be confusing later when you start using the tools and like, what does this at least having and exactly 0, like what is all this stuff? So absence of something just means you found none, 0. Then once you've established that this person belongs here in the cohort, then you can specify that exit. And I went over that whole routine of, do they exit after a fixed number of days? Do they exit after a continuous observation? Or do they exit at the end of this observation period? According to this picture, they exited after a certain period of time. Maybe that was the continuous observation. Or I'm sorry, maybe that was a continuous exposure. So, Gautam? Did he leave? Ah! All right. So I'm right on time. we have 5 minutes left in this. I'm happy to answer any questions. Did this all make sense to everybody? Some nods? It's all right? It can be as complicated as you want to make it. And as you will find later when we go through the cohort definitions, some of this may sound so simple. Like when I do the example of a new user cohort, you're going to be like, that's it? That's stupid. Like it's so simple. But you can also make it much more complicated using nesting and really what a lot of our discussion could turn into is finding the perfect code list. Like, does this code really represent the condition of interest that we're really talking about? And you'll find papers that dispute one code or another code, and the coding practice changed over years. So you're going to basically have to do things like find this code in this time range because that's what it was used for then, but they actually changed the methodology around that. So it's either going to be a code in this range or a different code in a different range of time, and it can get really complicated and very thoughtful about how these cohort definitions are. So I keep talking. Please ask questions. Yes, Rima, go ahead. I'll get to you.
Regarding gaps between observations, when you establish that you need continuous presence of
Yep.
a certain observation, does it correlate with condition and drug errors? Is that how you do it actually?
So there should be no, and this may change for CDM-V6, but I'll just give you what my current understanding and what I think the current practice is. Should be no data points found in your data that fall outside the bounds of a observation period. Like that is what the rule should be. So when you look for data and you have a start and an end date, it will fall within some observation period somewhere.
But if you have discrete records, right?
Yep.
Let's say you have two conditions, same condition, recorded multiple times.
Yep.
Build condition errors to build one.
Yeah, the condition errors will not span those observation periods. They should not span those observation periods.
My question
I'm
is
sorry.
the gaps between those observations.
Oh.
The third criteria, you have the entry, you have the exit criteria, and then you have the gaps covering.
Right.
Covering the gaps, and you have that
Yes.
time period.
Yes.
That is aligned with the condition and drug error.
I understand. I'm sorry. I was hearing observation period and the whole continuous. So that particular element, is it aligned to the condition error and drug error? No, because that's what you're building with your cohort definition. The process is you're building those moments of what you said the person belongs into the cohort. So think of those as cohort errors and not drug errors, not condition errors. Condition and drug errors are specific elements of the CDM based on conditions and drug exposures. Like condition occurrence derives into condition error, drug exposure derives into drug error. So if I'm answering your question properly,
I'm not formulating a full question. For example, your criteria is I'm looking for a cancer patient who had a breast cancer diagnosis prior to a certain time point. And
Okay.
That's my cohort entry.
yes.
And patients who has been having radiation therapy treatment.
Mm-hmm.
And do I have, and the radiation therapy treatments for, let's say, for 6 months since the diagnosis. And these radiation therapy treatments are discrete records with start and end, which could be one date.
Right.
The gaps between those treatments,
Yep.
how do you define them to make?
Good question. So, if I may, so we're saying that we have a cohort that diagnosed with breast cancer, and we're going to say that we want to make the cohort presence be while they're receiving the treatments. So you can in the continuous drug exposure, so the continuous drug exposure exit, right there you can specify what drug occurrences do you want. So it can be across any number of ingredients. Remember, drug error is single ingredient. But with this thing, you can give it the list of all the different drugs that could be used in chemotherapy or whatever to basically create those moments in time part of the setting of that, you can say how much time between those exposures will you allow to be considered you're still receiving treatment. And then when you talk about that in terms of the cohort exit, it goes from the cohort entry date. You told it what drugs to look for to make it continuous. You've specified in the code or in the actual query how much time should you allow between those individual things to consider them part of the same episode of care. And then all those things get chained together into a unique, completely for this cohort era. And that end date will be the end date of the cohort entry. So it can be based off of drug, it could look like a drug era, but it's totally, you defined it in the specification.
It doesn't depend on the presence of drug error, condition error, it would be based on procedures or any other.
I would say for now, that particular thing is specifically going to look in the drug exposure table and take those, because it's going to do things like add to the day supply and all this other stuff. There is talk, however, about saying that after you've established your entry event, let's actually pick anything, procedures, like let's say you're going into physical therapy and you are getting this drug, and as long as we see these set of things within a certain window with each other, you're still considered part of the cohort. Today, that's not one of them. It's not at arbitrary events. It's either till the end of the observation period, it's from the drug exposure table, or you give it a fixed number of days. And that is your three choices today. What you're describing is cool, and something I think is in the works is to be able to say, I want to look for data from any domain. As long as you have this, as long as this keeps going, as long as this keeps you in the room, forget about inclusion rules at this point. At this point, we've already established you're in, but now we want to look for these different events from the different domains to keep you here. That's what you're describing. Today, the only thing that'll let you use is drug exposure records in that way, to basically select the drug exposures, specify the windows, and then collate that all together. And once that finishes, then you're out of the cohort. So that's what we have. And we'll totally see that example today. Any other questions? Yeah, oh, that's right.
Yeah, question. Don't know if you want to take it now, but we do a lot of mappings, and when you do the mapping, you have to already make a lot of decisions, right? For example, you have to decide on observation period. How are you going to apply the rules from the source data?
And it sounds like you're describing the ETL process.
Yeah, the ETL process.
Gotcha. Mm-hmm.
So what I'm also here for today, and I'm wondering about a lot, is when you're doing research, you're building your cohorts, you're dependent on the decisions that were taken in the ETL process.
Absolutely. Absolutely.
And yeah.
So that gives you some worry, right?
Yeah.
Like you're like, what do I have to know about my ETL to do it right?
Sometimes I'm wondering, should we actually make multiple conversions to the CDM of this data set for particular research purposes? So, do you have examples of this interaction between, let's say, the choices that we make during ETL and the choices you make in the cohort building?
Right. So it's a very important question that you raise, and a very important point. So I'll unpack that a little bit and just talk about standardization of ETLing. So there are Themis groups, it's called the Themis groups, that basically gives you the recommendations of what you're supposed to do in certain circumstances, such as if a person has multiple birth years, do you keep them? Do you use the latest one? Do you use the earliest one? Like, what do you do? Other things that you're alluding to, as far as like there's certain considerations in the data that is going to govern how I define my cohorts, because I'm making the logic of my cohort definition like compatible with the logic of the data set. That totally happens, and that can happen. And what you suffer from is generalizability of your cohort definition. If you want to take part in a network study, but you have all these rules in your cohort definition specifically about your ETL assumptions, then your cohort definition isn't that transportable, and it may not be, and it is a challenge in standardization. So to answer or to address the problem that you're describing, we just all have to come to some sort of consensus about how you handle these data considerations consistently, so that when I make this assumption about the data, such as observation period, like what are we saying about observation period? We're saying that the assumption is that when you have an observation period, that you can trust that if you didn't find something in the data, it didn't really happen. Like that's what we're saying about observation period. Some people have very strict requirements that unless I have the machine hooked up to you, we don't know what's going on with you. And so you have these very finite groups of observation periods, and then you're limited to the type of research you can do. You have a cohort definition that wants 365 days prior, it ain't going to work on that kind of data set. And that's not a fault of anybody's, that's just how they decided to define their data sets. To your point about what if I made a very strict observation period version of the CDM, and what if I made a looser observation period version of the CDM? That is totally appropriate. You could totally do that if you want to make multiple, builds, and then you run the analysis, and in one case you'll get nobody in your cohort, in another case you found people. But perhaps you can't be that certain based on your data that when I said this couldn't be here, it might have been there because I don't really have as much observation. But again, it's that trade-off. So to answer your question, I think that you do have to consider when creating your cohort definitions where that cohort definition is going to be applied to. Absolutely. In fact, you can make cohort definitions that use source codes, what we call source codes, like ICD-9s. You can make a cohort definition that leverages ICD-9s. From an OHDSI perspective, do not do it, because we want you to be able to take and share your cohort definition with other people. And right now, we map over to SNOMED. But that doesn't work, as you heard yesterday, for like Korea. It's too expensive to do SNOMED. So creating cohort definitions for Korea that uses SNOMED is like, it's not going to work. But you can make two versions of a cohort definition that if you ran it on a Korean data source, get a characterization, take the standard-based cohort definition, run it on a US claims data, compare the prevalence of covariates. And if they seem pretty much balanced, then you could say that, hey, I think that we can use their cohort definition for their data sources, use this cohort definition for this data source, and do the same type of study, because it seems to have the right. It's encapsulating the same phenotype of people that we're looking at. So Gautam, we are ready when you are.
Okay. It's a new user design it will identify people who are prescribed oral anticoagulants. They talk about those oral anticoagulants. They talk about warfarin, dabigatran, rivaroxaban, and apixaban. They have defined these 4 drugs. They want to identify people in those data sets that are new users of these drugs. They said these people have to have certain age criteria. And they said the age has to be between 21 to 99. They talked about something about an entry date, which was defined as the date of first prescription of the anticoagulant drugs. They talked about some exclusions. They said if they've had any anticoagulant prescription in the last 12 months before the entry date. So what does that mean? What does that exclusion mean?
They're looking only at 2 drugs, and they don't want to include any other anticoagulant.
Yeah. So if they're looking at those 4, warfarin, dabigatran, rivaroxaban, and apixaban, and if somebody started them on dabigatran, but in the past they had warfarin or rivaroxaban, they are not eligible for this study. So it has to be new users of this, the first prescription of these drugs. That is how the investigators have defined this. They've also done other exclusions. They said they would exclude if they had either fewer than 12 months of records before entry. What does that mean? Observation periods before what?
Before the entry date.
Before entry date. So they should have at least 12 months of observation before the entry date. They should not have had any other anticoagulants in the past 12 months before the first prescription of the anticoagulants of interest. They should belong to the certain age range, and this has to be in a certain calendar period too. They said for the study period of January 2011 onwards, and so on and so forth. Right? So they specified some criteria. Now, once they identified this, they said we did some follow-up on these people. So they started on the date they got the prescription, and they followed them. They followed their first prescription of anticoagulant until they experienced an outcome of interest or were censored. What does that mean? Censored would mean they left. Died, left. That means we don't know anything about them. We are done, right? And what does that mean by experience and outcome of interest? An adverse event. So if they have an outcome, once they have it, we're not going to look at them anymore. They're done. Okay, perfect. They also did some rules for censoring. They said censoring is defined as they stopped or suspended the treatment. Suspended means they stopped taking the drug for 30 days. If there's a gap of 30 days, or they switched treatment. So if they switched from warfarin to apixaban or rivaroxaban to dabigatran, they are going to censor the patient on the date of switching. Or they left a practice, or they died. So these are some of the criterias that were used by the investigators to build the study. So can you imagine how the investigator may have done this? They probably wrote a very complex SQL query. Anybody can write this complex SQL query? Fantastic. Okay. How long would it take for you? 2 days. Okay. Can you? How about also as part of your paper? Come on. As part of your paper, you create an attrition diagram, right? You have to say, I found 20,000 people who had this drug, and an X number of people were excluded because they did not meet the age criteria of 21 to 99. I excluded so many people because they had this drug before the first date. If you want all those information, how much more SQL queries do you have to write?
Each is another joint, right? Or another workflows.
It's a good use of your time, absolutely. So what we want to show is how do we use the OHDSI framework to reproduce all of those content using what this ecosystem offers. But to do that, we have certain rules. And if this works, we would show you those rules. So this form of an attrition diagram would probably take a significant amount of work to compile. There will be a lot of complex queries. So these are where the investigator applied the criteria, so of what to include and what to exclude. Okay, all right. So using the ecosystem of tools, we want to get to this state, because if you can get to this content easily, you can write your manuscript and disseminate your findings. So the next 1.5 hours, we will be talking about how to use the OHDSI tools to replicate the content of this study, but to generate content like this. In this paper, this is a screenshot from the paper that you have as homework. What you can see is there is an attrition diagram. You start from 304,000 people. There are a certain number of people that were excluded because they had anticoagulants in the past 12 months, or they had more than one anticoagulant prescribed, or they had some other exclusion category that the investigator has pre-specified. Now, once they have met all the inclusion and exclusion criteria, you have a total number of people. Those total number of people are represented in this table here. So the different types of comparison groups are warfarin, dabigatran, rivaroxaban, and apixaban. These are the 4 groups that the investigator wants to compare amongst each other. They want to compare them for certain types of outcomes. The outcomes are major bleeding, intracranial bleed, hematuria, hemoptysis, all GI bleed, and upper GI bleed. In the OHDSI framework, each one of these is a cohort. Warfarin cohort, dabigatran cohort, rivaroxaban cohort, and apixaban cohort. In fact, all of those outcomes that we are interested in is also a cohort. So you have major bleeding, intracranial bleed, hematuria, hemoptysis, all GI bleed, and upper GI bleed. So as part of the next set of exercises, we have to define these. What are the criteria that we have to use to build these types of cohorts?
Can I ask a quick question?
Absolutely.
So, according to the study design, they're facilitating the direct comparison between the direct oral anticoagulants with warfarin. So, I'm assuming that when you look at your cohorts, that besides warfarin, the rest of them are the dogs, remember, the direct oral. So, even though they are, I guess we would need to separate them based on how the study made them. But
Yep.
even though we are going to compare them as this, as one versus the other,
Yep.
we still have to create them as separate cohorts.
Yeah, so,
That's how they're reporting. That's exactly what you said. They're talking about them as DOACs,
Yeah.
but what they're reporting is this specific comparison between one and the other.
yeah,
So over there, we'll see that like Riva and warfarin, they will each have their own hazard ratio effects with each other. In other words, they didn't group all those ingredients and compare it to
So in the
warfarin.
paper, they didn't group them, because when they say
They did
that
not.
they're actually comparing, the group of four, the anticoagulants with the warfarin, that
Right.
actually what they did was actually look at the paired.
Exactly.
Correct.
They paired the
They
comparisons.
grouped it in language, but they did not group it in
In that.
the actual study.
right. So absolutely, so that if the investigator is trying to do a direct comparison between new uses of direct oral anticoagulants against new uses of warfarin. So although they have in this sentence said direct oral anticoagulants, they are comparing each one of those direct oral anticoagulants against warfarin. So they are comparing rivaroxaban to warfarin, apixaban to warfarin, and so on. Perfect. So that's why it's been split out here and they have not grouped it. But we have the option of grouping it if we want to. So Chris probably talked to you about this, different types of cohorts in the OHDSI ecosystem. Based on the review of the study design, what is the target cohort of this study?
First time warfarin.
First time warfarin could be the target cohort, yeah. So if you look at this here, we are comparing it to, they want to compare it to something. What are they comparing with?
First time DOACs.
DOAC. So you could potentially interpret this as people who are on warfarin compared with first-time users of DOACs, right? So that's a possibility, absolutely. So so we have target cohort, people on warfarin. We have comparator cohort, that's what we are comparing with, directly acting oral anticoagulants. And as you rightfully pointed out, each of those drugs is a cohort. So now we have 4 cohorts, warfarin and 3 others. What are the, go ahead.
What about the lower doses of apixaban?
Lower,
Reporting on that, so there's 2 cohorts there.
that can be additional cohorts, absolutely. So those seem to be sub-analysis that were reported in this paper, right? So they could be additional cohorts. So what were the outcomes? What are the outcome cohorts? Major bleeding?
Which led to hospital admission of the
Yep. Yeah. So when you look at the paper and looked at that table, the different types of outcomes were ischemic stroke, venous thromboembolism, hematuria, hemoptysis, lower GI bleed, and death. Those were the outcomes that we found. Go ahead.
Yeah, I get always confused between this target and comparator. Like, why wouldn't they be the other way around?
It could be. So you want to answer?
I think the answer to that is depending on how you want to see the answer, like a
Yeah.
twofold increase in risk means that what you were comparing to had that higher increased risk. So when you flip it, you're either going to look at it from a increased risk of something or a decreased risk of something if you flipped it. So all of the T and the C, they're still comparing together. It's just which side of the no effect is that one line. So you'd either see a 2-fold or a 0.5-fold kind of thing if you switch the T and the C.
Yeah.
So it's just based on how you want to state the question. What is
Yeah.
the increased risk of something compared to taking warfarin compared to that?
And not.
So it goes back to the question, though. It goes back to how you ask the question.
Yeah, but in this case, what they're interested in is, are those DOACs more dangerous than warfarin, right?
Yeah. When they say more dangerous, what they really are saying is there an increased risk of GI bleed? Is there an increased risk of stroke? And so, more dangerous, less dangerous. What you'll actually find in some cases is that you had an increase of stroke, but a less decreased risk of GI bleeding compared to these things, like doing the comparison. So It depends on how, so this is getting into a whole like benefit risk analysis statement, but I was just saying that it's not always just a statement of dangerous, it's about what's the increased risk of one over the other.
Right. So if you think about this in a clinical fashion, for this particular research question, warfarin was probably one of the first anticoagulants in the market. DOACs were the ones that came after. So you probably have a lot of experience with warfarin, and now you want to compare that to something new. And there are many of those. So now you want to compare warfarin with that new one, with another new one, with another new one. So using that based on that logic, clinical logic, in this particular case, you choose target and comparator. Go ahead, Rima.
Maybe I'm going ahead of time, but essentially you're talking about multiple cohorts that comprise this cohort. Essentially, all the participants of this cohort should share all the inclusion criteria, all the outcome events, except that there are two arms, one on warfarin, right, and the other on
One of the three DOACs.
any other newer drugs, right? So it's actually an overlap of all other conditions, but separation based on warfarin.
The first use of the drug, absolutely.
And you will show us how to.
Just want to confirm the baseline is the target cohort, right? Baseline is the target cohort.
Yes.
Let me understand.
Baseline.
When you say baseline, it is the cohort entry. I would call the baseline the cohort entry. And so both cohorts, target and comparator, have a person enters the cohort. Either your target or comparator, doesn't matter. When you enter the cohort, that is your baseline. And so if you want to look at your comorbidities at baseline, you're basically saying, what were my prior conditions as of my initiation of this treatment? So every person has a baseline. Not every person has the same baseline because I started mine in 2013, they started theirs in 2011. But when they initiated treatment, that is, everybody is lined up to the same, like they're starting the race into getting to an outcome. And some people from their baseline will go 30 days at the outcome, some will go 45 days at the outcome. And so I'm just telling you what my interpretation of when somebody says baseline, we're just basically talking about their index or their cohort entry. Is that in line with what you're describing as a baseline?
I mean baseline is more like when you say the increase of the risk. So the base is the target cohort and the increase is the comparator.
I hear what you're saying, right. So when you're talking about the increase of risk, you're talking about a ratio of outcomes. And that's one way of looking at it. Like you have an odds of an outcome from one group, you have an odds of an outcome of another one.
Right.
Bring them together, it's an odds ratio. And if one has a higher odds ratio than the other, that means you increased your risk of having the outcome. So I just wouldn't use the term baseline, although now I understand what you're saying. Warfarin, in this case, is sort of a baseline in the sense that warfarin doesn't compare to itself. We're basically, I see what you're saying. Warfarin is like the basis. We're going to either see more increase or decreased risk based on what warfarin is as like the center line. So yes, you're absolutely right at that. So I see what you mean as far as like what the basis
But
is.
I think from a terminology is very important because it helps for ease of communication. So in the OHDSI ecosystem, when we use the word baseline, that means characteristics of the people as of cohort start date. So that could belong to any cohort. It could be the target cohort, the outcome cohort, or the comparator cohort, or even the negative controls and all those other cohorts that we have in the ecosystem. So, but in your context that you're talking to is, if warfarin, what is the risk of people of having the outcome among warfarin? And if that is defined as baseline, compared to that baseline, is the DOACs 1.2 times higher or 0.8 times higher? So that's a different interpretation of the word baseline, which is different from how we use in the OHDSI ecosystem. So baseline would mean characteristics of the cohort on cohort start date.
Right, and that's what I was trying to. However, I would say in the language of the document, they use the word reference. So they had the warfarin's the reference, and so when I see 1.2 in DABI, that means it was 1.2 increased. If I saw 0.7 DABI, it would be a decreased risk, but of the reference is warfarin.
So the reference is the target or the comparator?
Oh, well, good question. I would say target.
What
Yeah,
you wrote
yeah,
there,
target.
That's
Yeah,
the target.
yeah.
It's the
Warfarin will
target.
always be the target compared to DAOC1, DAOC2, DAOC3, DAOC4.
Yeah, and that, going back to the research question, we have so much more experience with warfarin, and the DOACs are new, so warfarin was chosen as the reference. So yes, you could use the word reference, but we use the word target.
Yeah, I think that, no, I was thinking that if this was RCT, probably would be different because in that case we need to demonstrate the non-inferiority of the DOACs in comparison to warfarin that has been around for decades, and probably the effects have been published hundreds of times.
Yeah.
But since this is not an RCT, probably then the target would be warfarin. If it was an RCT, warfarin would be the comparator or the control.
Yeah, yeah, and so, and that's one of the motivation reason behind why we use target and comparator. Absolutely.
I hear a lot of usage of index date as a baseline there. Is there any difference in your mind of usability of one versus another?
I think
Is
index
the
and
industry
baseline are
index
pretty.
is used a
I
lot?
think you can use interchangeably the index and the baseline.
Okay.
I think that's fair. Although in the cohort definition, index will be usually referring to the cohort entry, but there are certain maneuvers you can do where the index basically is just a way of saying referenced around, like a reference point kind of thing. So I would say, for purposes of just the cohort entry, index and baseline is synonymous. But we'll see where index is actually an overloaded term
For-
in cohort definition.
Yeah, and there are exceptions to that, and
Yeah, I'm sure.
we don't want to. Yeah, it's absolutely good question. We use the word index date. It is very close to baseline, because the reason is there is a difference between index date and we'll come to that. It's stepping a little ahead. So everything that we do in the OHDSI ecosystem is on person-level data sets. Person-level data sets are time-stamped information about people. So a person may have more than one record, and each record is time-stamped and has a concept ID associated with that record. Those concepts, those records are distributed over different domains. So we have different domains like conditions, drugs, procedures, measurements, and so on. So if there is another tutorial on the OMOP Common Data Model and vocabulary, which is extremely important. This is an advanced tutorial. So the assumption here is that you understand the OMOP Common Data Model, at least it is at its foundation level. So in the OMOP Common Data Model, at a high level, every person's information is represented in multiple tables. And this diagram here could be one person's experience over time. The person was started on a treatment right here. Before that, they were diagnosed with a disease, and after that, they had a particular outcome, and so on. All of this is represented in the CDM. And now we are querying the CDM to build a cohort. This is a screenshot from a tool called Atlas. How many of you are already familiar with Atlas and have used it? So about a big chunk of the class has already used Atlas. Have you used Atlas to actually do a study? Maybe just trying? Okay. So we hope that at the end of this class you'll feel much more comfortable using Atlas. Some of the feedback that we have received is, at least I've received, is Atlas is a really complex tool. And what Chris has done in this past month or so for this release is try to refactor the design of this UI to make it easier to understand. And this is our first attempt to explain how Atlas actually works. So, please give us feedback after the class, because based on your feedback, we may make it much more simpler. So there are 4 foundational sections in Atlas. They are the cohort entry event, which is this box here. There is inclusion criteria, which is this box here. There is a cohort exit criteria, which is this box, and there's a cohort error. This and only this field is a required field. Everything else is optional fields. So this is your initial thing that you would do to pull a list of all records to continue to work on. So if you think about that attrition diagram that went from 320,000 all the way till the study criteria, the actual number of people that met the criteria, that particular box here, and Chris, frown if I'm going.
It's true that they started with, I started with so many people to begin, and then I started saying age, get rid of some. And then they said had to have no other anticoagulants. Oh, got rid of some others. And that is true. That is representing how you start off with your candidates, and then you get fined down to the people that actually qualify.
Yep. So let me make one more statement. In that attrition diagram that's over here, this is your cohort entry events. All of these are your inclusion criteria in Atlas World. So if you want information as how many people did not meet certain criteria, then to throw people out, you put those rules in this box, the inclusion criteria section. This one is that initial top, the number of people who were dispensed this drug kind of thing. Does that make sense? The difference between these two? Fair? So based on that, let's go through the exercise of specifying what was cohort entry event, inclusion criteria, and so on.
Well, just the event index, for example, in this paper, they said they went through 2011, 2016, and then they went a year's observation before that, people that weren't on drugs. So is the event index day January 1st, 2010, or January 1st, 2011?
The event index date is the date they were dispensed the drug.
So that'd be the January 1st, 2011?
Nope, it would be between 2011. Within 2011, they were enrolling people, which means you could be February 1st, that's when you initiated treatment, or March or July.
Right, but the index date would be assuming if you're doing, since they didn't say what month, you'd assume January 1st, that the index date would be the first day of 2011 that you want to begin looking for.
That might be the enrollment start, but the index is when you actually don't enter the cohort until you take that drug. So I know what you're saying, but I'm trying to correct the language. The index date in this case is when you started your treatment.
So the index date applies to the person, not the whole study.
That is absolutely
Correct.
right. That is absolutely right.
Correct.
That's a good way of putting it. I'm like, how am I gonna? Yes, everybody has their own index date.
Okay.
And
Yeah. Your question, I think, is based on this sentence here for a study period from January 2011 and so on, right?
I was
Yes.
thinking that we needed to set the event index date, and I don't see how to set that. But now that you say it applies per person, now
the data will tell you what the index is for the person.
Gotcha.
Okay. All right. For those target cohorts, warfarin, and those comparator cohorts, dabigatran, rivaroxaban, apixaban, what are the initial index events that entered a person into the cohort? Perfect. First time drug exposure, right? Anything else?
Between 2011 and 2016.
So the first time drug exposure has to be between that 2011 to 2000 whatever, right? What else? Age could be, okay? All right, let's see. So the first prescription of dabigatran, rivaroxaban, apixaban, that's the target. And then you have warfarin. You had additional rules that you talked about. There was the rule about the observation period. They should have had observation for at least 12 months before the index event. And this has to be the first event, right? Because they're new users. It can't be the second, it can't be the third, it has to be the first.
This makes more sense to me, to put the targets like this and to go warfarin and compare it. Because you had it different to the other side.
I see the difference.
Sure, yeah, I was on that too. It depends how you want to state your answer to your question. When you say targeting this compared to that, the number you're going to get is assuming that there was the ratio or use the term baseline, that the relative risk of one over the other, and which is the T, which is the C is very important. And I believe T would be the reference and C would be the comparator, although up to this point we have been saying like, oh, you changed it.
I just changed it.
I'm like, what? All right, good job.
Go ahead.
So the first event means that the patient undertakes this drug for the past 12 months, but does not exclude the possibility before 12 months.
So the question is, does first event mean that the person did not take the drug in the past 12 months? The way we interpreted the paper was, in the history of the database, there is no record of the drug for the person.
So it would be more than 12 months.
Could be more than 12 months, yes.
There
The
has to be
12,
at least 12 months.
At least.
so we could have information about the person for more than 12 months, but we should at least have information for that person for 12 months.
And that first exposure has to happen after those 12 months, right? Because they said that you have to have no prior anticoagulants. Pretty sure that, not to confuse anyone, pretty sure that we are going to say that the first exposure happened after their 12 months of records.
Right, by default, yes.
Yeah.
By default.
When they say at that time of that first exposure, you must have had 12 months of records, they're basically saying at least 12 months
Right.
of prior observation
So if
before that very first exposure.
So if somebody got a drug on June 1st, 2015, but they entered the database on January 1st, 2015, they would not be eligible because they only had 6 months of history, not 12 months of history.
They have to be proven to be naive for at least 12 months.
Correct. I think that is true, but I would see it in a different way. We should have at least 12 months of data on this person to be able to get enough covariates. Because sometimes what happens is when somebody just enters a database, they may not have seen enough doctors or had lab tests that their comorbid conditions may not be captured yet. So that's another rationale. I don't know if the investigator used that rationale or not, but that's a common rule. All right, so let's go to the next box, the inclusion criteria. What were the other things that were specified in the study specification that may be used as inclusion criteria? Age. What else? Towns. Only oral anticoagulants. Yeah. Can that be part of the initial entry events? Okay.
They haven't been on other anticoagulants 12 months prior.
Yeah, perfect. So if you identify people with initial entry events, now if you find people who've had other anticoagulants in the past, you may want to take them out. What else?
Continuity of the order or prescription.
You're talking about they should be continuing to take the drug for a certain period of time.
Outcome of interest is fine.
Okay, perfect. So that we'll cover that in the next slide because we have the construct of cohort exit. So right now we're talking about entry events, the date that they met that initial criteria. So we are looking to apply certain inclusion criteria on that entry date. Okay.
You're picking up on a very important subtle point, though, about how they talk about cohorts and the definition of them in the paper. And that is, they mentioned that they are in the cohort until they have the outcome of interest. Or they didn't quite say it that way. They said we follow people until they have the outcome of interest or they leave the data. And the important point on that is it makes you feel like you should talk about that when doing the cohort definition. But in fact, you don't. You basically, if we're talking about continuous exposure to the treatment among first-time users, then the outcome of interest, we don't really want to care about what the outcome of interest is because they've defined 7 outcomes of interest. And we don't want to say treatment ending with bleeding, treatment ending with stroke, treatment. We're not going to define all of those cohorts. What they mean to say is that when we try to determine the follow-up time for a person, we will stop when we either get to the outcome of interest or there is no more follow to be had of the person. And seeing it written where they wrote it, it makes it feel like they're defining the population. They're not. They're describing how the follow-up time for calculating the risk is going to be used and accumulated. So it sounded for a second you were alluding to how the exit is when the outcome of interest happens. But for purposes of actually defining treatment, the treatment is just about what keeps you treated. You could die, and that's true, and I feel like death and mortality is sort of an exception. You can't be treated if you're dead, that's absolutely true. But for all the other cohorts, for all the other outcomes, you could get a bleeding event and just continue to be treated, and then after the bleeding event, you may have the stroke, which will result in a different calculation for the stroke outcome rate. So all this is to say is that although they like to say in these papers that we follow them until, and they start talking about outcomes, from an OHDSI perspective, treatment is the cohort, and while you're on treatment, that is your time in the cohort. And then when we want to look for the analysis, we want to do the outcome rate thing, we have the cohorts of the outcome. And what we would say in OHDSI is we will follow you in the cohort until we find you in a different cohort, in the outcome cohort. And that lets us use one cohort that establishes your time and other cohorts to establish when you've had outcomes.
Yeah.
So in simple words, if I understand it right, the OHDSI way is that C, the most common parameter of understanding what the baseline, or the basic cohort sounds like. And then the moment we say that if, when, how, what, things come in, that's the time we want to put the patients in the exclusion criteria cohort and try to put them in the second and try to exclude any kind of occurrence. So the inclusion criteria is pure and just the right patients, and we have absolutely no possibility of including any of the exclusion criteria patients.
Sure, that's when you're talking about your treatment cohort. When you talk about inclusion exclusions, you're like, we want to get the treatment of people who are treating a disease. So like you're treating hypertension, so that would be an inclusion rule. And then there'll something about the outcome that they're interested in may be confounded by, say, renal disease. So that might be an exclusion rule. We want to exclude people from the study that have like this renal disease, and like that would be an exclusion rule. But when we're looking at our outcomes of interest, we don't necessarily, and pretty much never, will like build one particular outcome of interest into the cohort definition. The cohort definition is simply saying, I'm targeting the phenotype of people I want to study. And they will all be present in that phenotype for a start and end date. That's the cohort start and end date. And then it sounded briefly again like you were trying to allude to outcomes should be somehow like excluded, or I don't.
What I'm saying is the moment it feels like that, there is there are conditions that we need to apply which may disqualify patients. Combine all of those conditions together and put them under the second cohort instead of saying.
Yes, that's that outcome cohort. Yes, absolutely. Yes, absolutely. That's it. You got it. Yes.
Well, and you're not going to generate this whole result in one query, are you? Because like, if you read through the paper, they want to look at a cohort that had the drugs with atrial fibrillation and without atrial fibrillation. So
yep.
If you could generate that all in one report, but you'd have to do one with and one without. Then
you'd make two cohorts for that.
Then you're going to have to compare those.
Good point. Good point. Right.
Right.
Reading the paper, right. Yeah, so absolutely. They do separate the results based on a prior AFib and no prior AFib. That would be two different cohorts, because you're basically saying the cohort that the phenotype is treated with the condition. They have evidence of the condition and they're taking a treatment. So that's one cohort. You have another cohort that's treated without the condition. There's zero occurrences of that, and that is another cohort. So even though we called out like there's 4 cohorts of the treatment, in fact there's 8 because they want to separate it by, what's wrong?
I feel, again, from the study design perspective, that we're looking at the 2 arms with equal, inclusion-exclusion criteria, and we're comparing the outcomes and dividing this cohorts by the outcomes, whether they had it.
Oh, the AFib wasn't an outcome. It was an indicator. It was an indication.
I'm sorry.
Yeah, you got it, yeah. Okay, no problem, no problem. It's all confusing. Yes?
Just going back to that previous point, I think, you said the Odyssey way is to do this. It's not really the Odyssey way, it's just the way. Cohort studies that you define your cohort only based on past events or past things. You never define your cohort by the future.
Right.
So the index date, you should only define people who get into the cohort at the index date based on whatever
Perfect.
the inclusion exclusion. Once you look into the future to define your cohort, you're in trouble.
Right.
It's not really a Odyssey way.
You're absolutely correct. This is a study design, study method. So, just going back to the Atlas 4-step framework, you have entry events, inclusion criteria, exit criteria, and errors. All of these are designed with the motivation to create a record, a cohort record, that says for this person, this is the start date and this is the end date. So, entry events and inclusion criteria are rules that are applied around the start date. Exit criteria is the rules that is applied for this one, end date. Does that make sense? So, how long did the person stay in the cohort is something that is part of the exit criteria. And the errors. They come to go hand in hand. Errors is a little more complex, but errors brings this whole thing and combines them in a special way.
For example, if you had 2 entry events and you said, I want to follow them for, I'm going to say that they ended after a year. I can't think of the clinical background, but let's just say we had these events and we said extend that period for a year. Like you were going to be considered in the cohort for a year. Well, let's say their second event they had happened 6 months later and they extended for a year. If we just left that alone, we'd have this 6-month period of overlap, which violates the cohort record principle. One person can only have one span of time, all right? So the error is to take that first year, you got it, you have the second one that started 6 months later for a year. That means your total start and end time is a year and a half because you had the starting point, the full year, and then the remainder of the second episode's 6 months, right? If you can picture that in your head. Yes?
Because errors are not applicable for this one particular study.
Correct. Because we're only using the first exposure per person, we don't have to worry about the notion of they entered the cohort because of a different event and now we're going to do collapsing. This is treatment cohort, this new user cohort design is actually pretty simple from a context of we just want the first event, so that's easy, it's just going to be one per person. And then we are going to make specification on settings of once I know they started, how long are they going to continue? And according to the paper, it's based on they take the drugs within a certain time window. So we will show all that sort of how that setting works, but the new user cohort design is actually pretty straightforward from a conceptual perspective. It's
So-
like,
Actually, my misunderstanding was considering exit criteria as exclusion criteria. So that
there you go, right. Yeah.
Right.
Exclusion means you weren't even allowed in the first place.
Yeah.
And where exit is saying, okay, you're here, how long? And then that exit specification will say how long you should stay.
So, going back to the Atlas framework, entry events, the date they got the first drug, right? Inclusion criteria is all of those attrition rules that you apply. Both entry events and inclusion criteria applies to the cohort start date. This exit criteria is our rules to define the end date. You can define the end date as the last date that they took the drug, the date that they switched the drug, 1 year after the start date, 10 years after the start date. Any of those are exit rules that can be used to define the end date. Or it can be death, it can be something else. Go ahead.
So you're saying that each person could have different start date and end date.
Okay.
Then which means that they can have different period of drug taking time.
Yes.
And then we compare between the outcome with warfarin and with another DOAC. But the person can take the drug with different time period, right?
You mean calendar time? At different time, like...
Yeah, different 3 months, 6 months.
Right.
And I don't know, so with outcome due to the drug or due to the time they're taking?
Okay, so the question is, every person may have a different cohort period. Cohort period defined as cohort end date minus cohort start date. is the duration of therapy, can the duration of therapy explain the probability of bleeding? Right? That's
Yeah, also, I was thinking something along the same line. That I didn't see that on the paper, but do you also include in your inclusion criteria a minimum number of drug events in order for a patient to enter the cohort? Meaning that if there is one single drug event, it's not sufficient to trigger the different AEs. You could argue that
they should have at least 6 months of treatment before being part of the study, right?
But then you run into an issue of immortality, because if you say you must have survived for 6 months, then what? So I know what you're saying. Like, is it fair to compare somebody who's been taking it for a month versus 5 years? And so when you talk about Cox proportional hazards, you're saying the relative risk does not change over the time. Or actually, it has a constant rate of change. So the same person, the person that took it for 5 years was still at the same level of risk for that first month as the other person that only took it for a month after the first month. But the point is that both people should contribute that 1 month of time towards a survival ratio calculation. So I understand what you're saying about how, is it a fair comparison to have a person with one or the other?
Yeah.
When we talk about propensity score modeling and making two different populations comparable, part of it may be the total time at risk is a variable that you want to balance between both. So you're going to find the person who only took it for a month on the one arm. You're going to find the person that only took it for another month on the other arm. They become a strata of our hazard ratio. And then you have all these other strata of the people that took it for a year or longer, or however the design of the system works. But we are now talking about a method and calculating that rate ratio. So we are only talking about cohort definitions here. But your point is on par. That the point we're going to make is there's going to be people in the population with varying amounts of start and end date durations. There's just going to be that way. How you want to use that population to say, I want to stratify by duration of exposure. We'll go within a month, up to a year, more. And if you want to compare populations and take pieces and subpopulations of the cohorts based on those rules, because that's how you're designing your study, you are free to do so.
So in other words, if your research question is, I don't care how long the person took the drug, I just want to know if the person took the drug or not, then you can make your cohort end date equal to cohort start date, and you're done. Because all you need to know is, took the drug or did not take the drug. But if you are interested in the question of duration of exposure, which is what you pointed out, then you may want to specify the cohort end date more clearly to be the last date that they took the drug, right? So if somebody took the drug for 9 months, they can be treated differently in your methods compared to somebody who took the drug for 9 years, compared to somebody who took the drug for 30 days. Does that make sense? So you can use methods like adjustment or proportional hazard model or things like that. And this framework supports it because now you're able to get the time at risk. So what is the cohort exit criteria as defined by this study? They come off the drug, the last date that they took the drug. What else? They died. So death is an interesting situation. One of the rules of the OMOP CDM is your observation end date, you stop the person's observation when they die, generally, right? Because you won't have any more data. So in a good CDM, you would generally expect the observation end date to be equal to the date of death, unless you can get, even after somebody is dead, you can get observations about them, which is practically not possible. Go ahead.
So is it cohort exit is the same as the being censored?
Yes.
Yes. So in other words, if you're following somebody and you get to their end date of their cohort without finding an outcome, then you would say they got censored. They didn't have the outcome, they just stopped contributing time at risk. They were censored. In fact, everybody gets censored in a study if you're going to say the study ends at a certain time, right? Like everybody gets censored. But so the difference between I was censored versus I got the outcome is I didn't get the outcome, therefore I must have been censored.
And from this,
Does that make sense?
So the exit, you would exit at the end day, but you would be censored if you did something like according to this, they didn't take the pill for 30 days, or they switched medication,
Yeah.
so they died.
Exactly, which means that we're saying your continuous exposure stopped. We're just calling that the cohort exit. You would call it they were censored because they ceased taking the drug. But how it gets represented in the cohort is that's their cohort end date. They no longer qualified, so they stopped. We call that censored.
It's the person in day, not the cohort. I guess I'm hearing you say that.
So so let me ask you this: when I say cohort end date, do you think that's a date applied equally to everyone? The cohort end date?
Yeah.
It is not.
Okay.
The cohort end date is for the given person. This is their date that they exit the cohort. There is no one date attached to a cohort in our design. If you said that everybody should enter the cohort on January 1st, and everybody should exit on December 31st, then everybody would share the dates, but everybody gets their own date.
Or if you globally stopped collecting data or some other outside contributor.
If coincidentally, due to some data artifact, everybody happened to have the same end
Yeah.
date, that is the way it is.
So-
But I'm just trying to say, you don't give an end date to a cohort.
Yeah.
You give the person will have an end date within the cohort.
so
But sometimes there is also study approval period, you know?
Yeah.
You can do it from 2010 to 2015. That's
And
it.
honestly, what I would do in that case is define your cohort as it is, and then when you want to study the population within that range, you trim everybody to that range. And people that don't even have a presence in that date range, they're not in the study. And the people that actually had presence in the cohort outside of that range, they get started when we want to start looking at them, and they will stop when we want to stop looking at them.
yeah. So
There is absolute reasons for having that idea in a study design. Like, there's a clinical practice that only took place in this time period. So we'll define our cohort as all the time, but we will study within a certain range. And that is a totally fair way to look at your cohort.
So Chris and I have gone through this several times,
That's true.
and finally was able to convince him. So I work for a health insurance company, and in our particular use cases, we want to study the people for whom we have sold an insurance product. Why? Because we want to advise the population about benefit design, or to figure out any risk profiles that we can negotiate with the hospital systems. So insurance is sold on a calendar year basis. Most of the time they start on January 1st and they end at December 31st. So your cohort definition is by default January 1st to December 31st. We may have them in the past, but our study is from January 1st to December 31st. So that was the criteria for the cohort definition. So we worked with Atlas to actually support that, where we can specify the same start date for everybody and the same end date for everybody. So it is possible to do that, and that is part of the errors at the bottom. So the errors are very special, and they allow you to manipulate your cohort definitions in a very special way. But going back to one of the fundamental points, every person has an observation period. That's the dark line, observation start date to observation end date. The blue arrows are cohort entry and cohort exit date. Your cohort dates cannot be outside the observation period. So by default, Atlas and tools in OHDSI will, at the maximum end date possible, is the observation period end date for the cohort. Does that make sense?
All right, so we should try to
What time
wrap
is
it
it?
up, because
Yeah,
it's almost
okay.
11:30. And,
All right. So the last one was the cohort exit. A cohort exit is the end of the study period, and it's we'll go through in more detail in this, and we're done. Errors really quick. So the concept of the cohort errors is not applicable for this study, but it is applicable for a scenario like this. So let's say you want to study what happened to people when they were admitted to the hospital. So you want to build a cohort of all the people who were in the hospital. You don't care about them after they leave the hospital. You want to know what happened inside the hospital. So you have several records, and then you build a cohort with a cohort start date, which is the date of admission, cohort end date, which is the date of discharge. But then a person may have multiple admissions. So you can have multiple admission end records for that same person, and each of those visit start date and visit end date can be a new cohort start date and cohort end date for that person. Maybe somebody got admitted within a short window of another admission, and you want to, in your study definition, say, they were just 5 days apart and they came back. I want to treat them as one continuous inpatient stay. So you can now construct eras by pre-specifying and say, if the end date of the previous record is within X amount of days of your first one, collapse them into continuous eras. So that is the construct of an era. And the eras also allows you to say, if somebody started on December 15th of 2015, I want to cut that and start them on January 1st of 2016. So you can do that.
So I will be doing some drawing because I think visualizations are very helpful to understand. So I'm going to create this in the final slides, whatever we talk about today. I'm going to have this is an observation period. Here's our cohort entries and exits. I have little symbols to represent this is the outcome of interest. And so when it comes to that, and we want to actually talk through an actual how does time at risk relate to the cohort start and end date, we can absolutely do that. But for now, what I'm going to do is talk about just defining a cohort in Atlas and actually get our first step done as far as let's start talking about our targets and comparator cohorts, okay? So if you guys want to pull up the Atlas, you can work on this through this, but considering our time, I think that it might be better just to watch, and then over lunch, you can go in and, try to do some of these actions on your own. So depends on how you want me to do this. Is that all right to basically just kind of walk you through it, and then when you guys get your next break, do it yourself, and then Gautam and I are here, Joel's here, we're all here to help you guys do what you want to do. But, so what I'm showing you here is...
Your font's pretty small.
Oh yeah, of course. Sorry about that. I think I can do it like that. A little better?
And from what I can see of the left-hand part of
So, oh, that projector. I was like, I can't get to that one. But that one I can get, yeah. I noticed that earlier, and I'm like, Okay. So we're at the main Atlas UI. To get to a new cohort, you can click right on Define a New Cohort, or you can click on the Cohort Definition module. We can do it that way. All right, I have a couple of created already, but we'll ignore those. To create a new cohort, we go ahead and click on the New Cohort button. And this will set up that UI that we kind of just pointed at earlier today, where we have our cohort entry events, a place to specify prior and continuous observation of prior and post continuous observation, inclusion rules, and etc. So, real quick, I know you guys know the answer, but just to keep the energy going and people awake. What domain, we haven't really talked about this, but what domain am I going to look for the entry events? Drug exposure? You said conditions. What's the target cohort? Right, is that going to be found in conditions or drugs? All right, so we're going to look in the drug exposure. I would also have accepted drug era, because drug eras are derived from drug exposure, and since we are looking for the first event, the beginning of a drug era will coincide with the first event of the drug exposure. So I would have accepted drug exposure or drug era, but we will go with drug exposure, that's fine. So I'm going to click on this button for adding, when it says add the initial event. This is the initial event, the cohort entry event. We have a drug exposure choice, and it just pops up a thing saying, okay, any drug. And we definitely don't want to just make a cohort of any drug. We want to get a cohort of the drug we want. Okay, so let's just tackle that right now. We are not going to get too much in vocabulary searching, but let's just say we need to represent the identifiers for the drug of interest, which in this case is what? All right, so all right, so when I click this drop down, the whole point of it is to basically say, if you have an existing code list, you can use it. But we just made a new cohort definition. There is nothing specified yet in this cohort definition from a code list perspective. So if you've ever tried to go through this yourself the very first time, you might have looked at this and said, like, what is this? So you need to get a new code list. And we're going to click on Import Cohort. There are code lists in the cohort tutorial that have already been defined, but I'm not going to import it now. I'm going to, because I want to go through the process. So we're not going to use an existing concept set. We're going to create a new one for the cohort. So I click on this button, New Concept Set. I'm going to name it warfarin. Great. So this is one thing very tricky about the Atlas UI. We are now looking at a concept set of warfarin. There is nothing in the concept set. We just created it. No records. So this is the confusing part of it. In order to get stuff into the concept set, we need to find it through searching the vocabulary. All these concepts that are in the concept set are vocabulary concepts. So just remember that. So we're going to go and we're going to search for the concepts of interest, okay? The way you know that you are going to be manipulating a certain concept set is at the top you see a little indicator saying I'm in this cohort of new users of warfarin and I'm in the concept set of warfarin. That's how you know you are manipulating this particular list of codes. And when we get more codes later, you'll see how to switch between them. But for now, we're looking at the new codes. Okay, so we want warfarin, so I'm just going to do it. So it's a search box. I'm just going to hit enter and search. Great, came back in enough time. There are different ways. This is a text search, so it looked for warfarin based on the term warfarin being in the name. You could also search for an ICD-9 code because there is a column here for code. So if you were looking for conditions and you wanted an ICD-9 code, you can type in the ICD-9 code. It'll search the code column as well. So it's looking for text. The reason why I say this is important is because if you looked for cancer, but in SNOMED it's a neoplasm, you're not going to find it, right? So so this right here is all about searching via text. Second thing I'll say is there's these ways to filter the results based on like what vocabulary it came from. So if you want to know all the stuff that comes from the NDC vocabulary for warfarin, you filter on that. If you're looking for what domain the concept is for, there's actually observations with the word warfarin in it. There's actually conditions with the word warfarin in it. What do you think they could buy? There's only 29, so we can just look at one just for the giggles. Poisoning by warfarin, So so there's actually code. So the point is that you wouldn't make a code list just off of a raw text search. You got to look at what is in the results. We know we're looking for drugs, so we can just filter by drugs. But I also know, I'll just tell you as a shortcut, we're going to be looking for ingredient. We're looking for the ingredient of warfarin, which happens to be a concept class in the vocabulary. But I'm just going to type ingredient in my little subfilter here to filter my results down to any rows that has the word ingredient. There it is. So we actually have some of these in red, some of these in blue. The red means that it's a non-standard concept. These concepts exist in the vocabulary, but they exist only for the purposes of mapping over to a standard concept. So you have all these other precise ingredient classes and stuff, but this is the one we want. We want warfarin. That's the ingredient concept we want for warfarin. So to add it to the concept set, again, not as obvious, there's these little shopping carts on the left. If you click it and it's red, it is added into your concept set now. And yeah, it's now the concept is in the thing. Yes.
A quick question. So when you do the search by warfarin, so is it a test string-based search like you?
Yeah, that's all it is. It's a string-based search.
So do you support fuzzy search?
So that's a good question. Right now, it's doing a like clause in the names of the columns. So speaking in terms of SQL, it's a substring search. However, we will be introducing fuzzy matching and fuzzy logic and term graphing kind of thing in this product called Solar. And it has more faster, in fact, indexing of all of the terms so that if there's a relationship between one term and the other, it'll come back. So But right now, it's a text-based search. It's a like, basically. It's a substring search. So, all right, so we got it. Now, just to show you that it's in here. Oh, yes?
Why would you put it you said blue means non-standard.
No, blue means standard, and red is non-standard. Sorry, there used to be a little, oh, here it is. So blue is standard, red is non-standard. Yeah. Just on that note of standard versus non-standard, you want to create your codes off of standard concepts because when you ETL the data from your external data into the CDM, you mark all of the records with standard concepts, not non-standard concepts. All right, so spending a little bit of time on just warfarin, just to, I was thinking I could do the search again and show you that this shopping cart will be pre-lit. If you have an active concept set and it has lots of concepts in it and you do a search, when you get your search results, any concept that's in the active concept set, the shopping cart will be lit up. I added it by clicking it, and I just removed it from my concept set by unselecting it. So adding and removing a concept to a concept set is simply toggling that button back and forth on that row of the search results. So just something to be aware of how it works. Yes?
Sorry, is there a way to, so if you navigate away after you've added this to your shopping cart,
Yep.
is there a way to get to your shopping cart to see what's there?
So it's a shopping cart design, like sort of pattern, but really it's the shopping cart you have, what's in it is in this view right here. This is my concept set in my cohort definition. So when I went back to search, it was, my active concept set is warfarin, and I added from what I just did, I just added warfarin to it, right? So I'm going to search for warfarin again. And this is just going to demonstrate what I was just saying, that when I search for the ingredients again, that it was lit up because it knows that's in my concept set. There's no notion, and I wish there was a notion of a shopping cart with this, and that's a pattern that we're going to try to move to in the future. But right now what this is you select a concept set to manipulate, you do your vocabulary searching, and then you add and remove into your active concept set. And the way you know you're on an active concept set is this little breadcrumb at the top. Yes?
So the filter will hit the class column. So the filter will hit all the columns.
Yep. So these values are coming from the values of the class column. So there is there's a marketed product, which I was filtering on ingredient. So marketed products aren't ingredients, they're something else. So I'll delete my filter here. So these are all the different, this is a class of the concept in the vocabulary of the marketed product. If you wanted to say cohort being exposed to this branded drug, then you could search for the concepts of the brand name of the drug, because there might be different brands. And if you want to do a comparison between one brand or the other, you could actually do that. But that's not what we're doing here. We're doing just warfarin. All right, so yes.
Yeah. The classification and the class, are they the same thing? You have the icon on the right bottom, standardized, non-standardized classification.
No, the classification versus class.
Classification.
Standard, non-standard classification.
Oh, I'm sorry, yes. They are not. So the class is an attribute of the concept, whereas a classification is used to basically say that you're not talking about a concrete idea of something. It's like, and all the concepts related to ATC class, if you're familiar with ATC classes, like all the concepts out of the ATC class vocabulary are used to classify groups of concepts together. So when we talk about classification here, we're just talking about this concept actually represents a broader term than a concrete standard class. And to be honest, it's a question of the vocabulary group to say, how come some of these guys are marked classification and others are marked standard concept? So I'm sorry, I don't want to get too far down the rabbit hole of nuances in the vocabulary. So just focus on standard concepts for today's exercises as far as identifying things to put into a concept set. So back to this, we have warfarin. Okay, so we added warfarin to our concept set. All right, the second thing I want to describe about concept sets is that you can leverage the vocabulary to bring in what we call descendants of warfarin. So if you think of a hierarchy, you have high-level terms that are broad, then below the hierarchy there's a little bit narrower terms. So underneath warfarin, you might find injectables versus oral, right? And then underneath the injectable, you have the actual infusion concepts, and under the oral, you have the tablet sizes. So the point of the beauty of the vocabulary is that I can take, from an ingredient drug perspective, I can pick up an ingredient and then use its descendants. So if we take a look at what's in the included concepts right now, the only included concept in this concept set is the concept I added, warfarin. Nothing else. That's not good enough, though, because people don't get warfarin. They get the pill, or they get, like, if it's injected, they get that, or cream, if it was a cream. So what we want to do to get the descendants from the vocabulary, we click the descendants button here, and it will pull in all of the descendant concepts. So if we take a look at now the included concepts, now there's 533 that came in just from clicking that one descendant button of warfarin. If I look for warfarin, and they're all going to say warfarin, not important. I was about to say that the one that I selected is definitely in this list, and you'd see it, but all the other ones that don't have a shopping cart aren't directly in the cohort. Like, I didn't add those to the cohort, but by using, I didn't add those to the concept set, but by using descendants of warfarin, they are going to be used. So this is just a vocabulary anomaly, a kind of function of the vocabulary. And yeah.
Can you exclude injectable?
Yes, you can. So why don't we search for warfarin again. And let's say inject. There we go. So let's say for some reason the 5 milligram injectable solution is not what we are going to consider as being warfarin. Let's say the dose was too low. I'm making this all up. I don't know what the rules. You want to know about exclusions, or how do I, not exclusion rules, but how do I remove certain codes from our concept set? So let's say I don't want to see any 5 milligram injectables, any descendants of that. They're gone. They should not be in this code list. So I found one of them that I want to get rid of. So I click on him. So now his code is in the concept set, but now I can decide how I want to use it. Do I want to use descendants, or do I want to exclude? So I can now go over to here, go back to my concept set expression, and here's the one I just added, the 5 milligram injectable solution. I want to say anything at that level and below should not appear in the result of the codes. So I click descendants, and now I click exclude. And I'm waiting for this button real quick to refresh here. Let's just give it a sec. Because it was probably already a descendant of the ingredient, we should still see 533 descendant included concepts here. Hopefully this will load.
I guess in the study they only wanted oral, so how do you exclude all injectable warfarin?
So I'll show you the search, but there is basically injectable warfarin, probably as a parent to the 5 milligram. It's probably just a general injectable, it's a dose form, and you can explain it. I don't know why that is not responding. Could be a...
There are some of the drugs that are injectable, some oral, some do not have that definition. So how do you know is the ones that do not have definition if they are oral or injectable?
They'd have to specify it in the study, I guess?
So they will select only oral. If it's not defined and explicitly exclude them, those drugs?
So I think the question is, if the name of the drug does not indicate whether it's an oral or injectable, how do you handle it?
Right.
Well, so if this was let me think about it. If this was an NDC code, right, or an RX norm code, you could potentially go to the actual code itself and look at the RX norm website and then see if there is.
Oh, well, that's handled by the vocabulary mapping. The vocabulary folks manage all these dose forms, and if there's a concept for warfarin injectable, then they have the hierarchy, and they will put everything that's an injectable underneath that. And I'm sorry, I think we lost network again, so I'm gonna try to steer clear of too much. Let me get to, I'll get you in just one sec. Go ahead.
On this one, you can't browse up and down the hierarchy.
You can. You absolutely can. Yes. Yep. And I will show that, but it requires a network. But so, go ahead. What's your question?
I was just going to ask, since we were on those three buttons, what does map do?
Okay. So, good question. It's something that I don't like talking about much, but yes. So, what map does is it will bring in to the code list anything that mapped to the standard concepts. So in other words, I have my warfarin ingredient, and let's say I have descendants and mapped. That means any NDC code, because that's what maps over to the RX norm. So any NDC code will be brought into this. And this is just as a shortcut that if you want to use source codes in your cohort definition, but you don't want to have to go through the thousands of NDC codes, you just can say, just bring in all the NDC codes that map to warfarin, and that'll just give you this whole list. So the reason why this is flipping over to this screen is because some server-side query is happening, and it's failing, probably because of the network. So, sadness.
Applied in order. You have the inclusions and exclusions.
Yes.
I've got one line with an
Yep.
inclusion, and a second line with an exclusion, another inclusion.
Yep.
And they're going to form triangles and they're going to overlap.
Yep. So I would say the way to think of it is that exclusions always apply last. So it's not like you can include and then exclude and then include and then exclude and then include. What happens is all the inclusion, the ones that are included, so it's either included or excluded. So the ones that are not excluded get pulled in as the set, and then you can weed out, then you set everything that's set to be excluded, takes whatever I included and subtracts it. So it's not a matter of, I know what you're getting at as far as it would be cool if it was a construction belt kind of thing where you can like put many layers and phases of include this, but then get rid of that, but then put these back and then include. It doesn't do that. What it does is just says, what are included, and then what do I need to subtract? It's that simple. It's simpler that way. All right, I think we actually got back, so that's nice. Yay, there we go. So you wanted, I'm going to jump on that actually right now. I'll just show you that because it's on your mind, and we might as well just do it, and I think we have network now, so. Okay, so I have a class, let me see. Yeah, sure, I think it would be under the class. It's like form. There we go, clinical drug form. No, all right, what did I think I did? Clinical drug form. There it is, you're right, sorry about that, all right.
If you would like this to be sorted in alphabetical order, please go to GitHub.
Frankly, I wish that was on a whitelist because some of these classes that show up is like, all right, so yeah, we can. So this in the vocabulary are all the different types of forms, dose forms that are registered for warfarin. And I have oral solution, oral suspension, or tablet. If I only wanted warfarin oral tablet, then I could put that into my code list, my concept set, and say descendants of oral tablet, and I only get oral tablets. But if I basically say I want everything except I don't want the injectable solution or suspension, and to be honest, I don't know the difference between solution and suspension, but let's just say if it's injectable, I don't want. So we'll add these two to my code list. I will exclude these descendants. And let's see if I have the network to. What I want to see is the included concepts number should come up with, yeah, so let's see what happens. I might have kind of lost network again. But that's how you would do this. If you said, I want all warfarin, but I want to exclude certain dose forms, you find the concept that represents the dose form and then exclude it from the list. All right, so I have a feeling this, again, we have connectivity issues. Okay, we haven't even gotten to criteria, like the main issue. I mean, we could, dealing with code lists and vocabulary, I highly recommend seeing the video vocabulary tutorials and also even go into the symposium classes. There's a lot to vocabularies, and we could totally spend many days talking about the different nuances of a mapping and hierarchy and what is a vocabulary and what makes it a standard concept. It's just all vocabulary talk. Whew. All right. So let's get to the inclusion rules. Let's actually, let's not get to the inclusion rules. Let's finish talking about which warfarin exposure records we want, okay? Is there a time window in the study? Was there a time window? When you could like kind of come in? Okay. Okay, so that means that whatever we find, the start date has to be between that time window, right? Now, they talked about an enrollment period. They said the study went up to 2016, but they said the enrollment, I believe, was 2010 or 2011. Wasn't it the 12 months of 2011 or something? So let's just do that here. So what we're going to say is the start date, I clicked on, added the start date, and we're going to say the start date was between 2011, let's say, and 2011, let's say 2012-01-01. Yes, it's fine. Okay, so that would get any exposure that was happening in that time window. But that is not what they're asking completely. They're saying, okay, well, yes, it has to be in that time window, but also it has to be the first exposure, right? So there is actually a criteria attribute for most, if not all, of the criteria types of the different domains that you can say like first. Like what's the first one? And what that does is it basically literally limits the event records that you are going to select to the first record it finds that belongs to that code list. Like whatever the first one is, I'll get it, okay? There's other ways of doing this where you could say the first one is the one that has 0 of those codes prior to it. But that would make this a little bit more cumbersome to write, to say, find me all events, but only if that event has no other events before it. Like, that is logically the first. The first has none before, right? So, but this is a simpler way of doing that. So this is a shortcut. But I just wanted to put into your head thinking in terms of events and the proximity of, like, first means 0 occurrences of prior to that event. That's what first is. Okay. The other thing they asked for is the continuous enrollment, right? How many months? 12 months. So we could state that right here, but I want to do it a little bit differently. But you could state it right here. You could say 365 days prior and 0 days post, and that would ensure that whatever event was the first had the 12 months of record at least before that person, okay? That's one way of doing this request, okay? But let's say we have a question about how many people did I actually lose because they didn't have the requisite amount of prior observation? That's like a good question because maybe 12 months is too strict and maybe we could get by with 9 months if it got us a couple more people. I mean, there's always got to be logical, reasonable reasons for picking a washout period or a continuous enrollment period. Like, so usually it's never a good reason to say I can get more people if I do this. But on the other hand, you know, you just want to know. You just want to know, is there some element of the data that's restricting these people? So I am going to leave this 0 for now, and I will handle the prior observation as an inclusion criteria. Sound good? That way I can actually say I could have had 200,000 people, but because of prior observation, it went to 20. Okay, yes?
Well, they said that they wanted at least one prescription of any oral anticoagulant between 2011 and 2016 with at least 1 year of data.
Okay, in that case, this should be 2016. All right, sorry. I could have sworn I saw their enrollment period was 12 months, but maybe I'm thinking of it.
They want 1 year of data, so you can enroll anytime between
Yeah.
1 year of data.
Okay, fair enough. So this is our time window of starting the exposure. They have to have the year. Okay, so let's actually do that one first. Here's how you do inclusion criteria. You go to the inclusion criteria, you click the button, new inclusion criteria. We're going to call this one the prior 12 months of records, because that's what they described it as. So we'll follow their description. Prior 12 months of records. Okay. So we're going to add a criteria to this. So the way these inclusion rule works is they are basically, they're Boolean operations. So you can say A and B and C, or you could say A or B or C, okay? So if I added, let's say it could be either a condition or a drug, okay? Then I would say that this criteria, this inclusion rule has to have any of these two things I'm defining. Either the condition, or, it says or, the drug. Let's say the inclusion rule said they had to have both. Then I'd say they have to have all of these. So now it says you have to have the condition and you have to have the drug. This is not what they're asking for in the paper. I just wanted to, as long as I was here in the UI, I just wanted to show you, okay? The reason why you have this add criteria to the group is basically saying it's giving you the option to do an and or sort of logic between these two criteria. But that's not what we want for the prior observation. Does anybody remember from what we talked about the tables in question with continuous observation? What table do we want to really talk about in this criteria? Observation period. So we're going to add an observation period criteria. Okay. So for purposes of consistency, whenever we talk about these type of criteria where you're counting something, you're always, with inclusion criteria, you're always saying, did I have at least one or did I have exactly zero? You know, you're counting things. So even though it makes no sense to try to count observation periods, we are saying we are going to be counting an observation period. And for this event, there's only going to be one observation period you're going to find for this event. So just putting that out there just to, like, if you feel confused about why do I have the choice to count observation periods, it's because it could have been, as we just saw, it could have been a drug exposure or condition occurrence, and you would have been counting those. So generically, when you talk about inclusion criteria, you're counting things to happen. So we're saying with our observation period, we want to find an observation period, right? That what is special about this observation period? Do you have a question?
Drugs. And that's what I wanted to ask actually.
Okay.
We are looking, our index event is drug exposure, correct?
We got that already. That's this guy, our index.
Well, and don't we want to narrow our prior observation periods to drugs only?
Observation periods are not restricted to.
I know, but that's what I'm asking.
Right.
Should we look in the observation period for that 12 months prior?
Yes, yes.
Should we look, what if there was condition?
So if it was a condition, you'd still ask the same question. Do I have an observation period that has enough prior time to when I got the diagnosis in the condition occurrence case? Or in this case, we're talking about drug exposures. So let's try to follow through here. So what are we saying about what will qualify this drug exposure about the observation period? Okay, what is it? What are we going to state about what must the observation period? And I'll give you kind of a hint. We're going to be talking about the observation period start date, right? What about the observation period start date would allow this drug exposure to count? Right, and so it's 12 months, right. So what has to be 12 months? The starting of the observation period has to be after 12 months of that. Sorry, so let's talk that through, right? So we have our observation period. We're saying we have to find an observation period that has, when it says the event starts, it's talking about the observation period starts between all time prior and 120 days, right? So we're basically saying, I'm sorry, not 120 days, 365 days, right? We're basically saying that the event has to start between, think of a window in your mind, there's a period that goes all the way all time prior, and it has to start after the 365-day mark. So we're creating a window of time that we are going to look for the observation period start. And it's that period of time is all time to 365 days before the drug exposure. In this case, remember I talked earlier about like index days are kind of loaded. In this case, the index date is the entry event that we talked about initially. And that initial event is the first use of the drug. So this could have selected 200,000 first uses because it was just the first record for the person. This criteria says it's not a real first use unless I know there was an observation period that began longer than 12 months before that record. Yeah, when you said this, yeah, that's the drug record of interest.
Are you trying to write the exclusion rule for if they had it before, or are you trying to make sure they have a minimum of at least?
I'm saying they have to have a minimum of it, so it's like an inclusion rule. You're in if you had the observation period long enough before. So I started with the hardest one, but does everybody okay with like just the use of the observation period table in this context?
What about if the observation ends this particular one before? Don't you need to give a criteria for the observation period ends
Yep, so let's do that. Good point. End the observation period, which is this event, ended all time after, or let's say between, can it end on the day? Yeah, it can end on the day, that's fine. So we'll say it ended between 0 days before and all days after the event start date. So that's basically saying exactly what you said. That's an excellent point. If we had an event start date, a first exposure that happened in some other observation period, right? And then we had this other observation period right here that is way further behind, we had to make sure that the observation period that we're looking at is the start and end of the observation period has to be within the event. It has to surround the event, it has to bound the event. So that's a very excellent point. You got it. That's what you had to do. And that's what we did just here. So we're saying the start had to be further than a year, and the end had to be after the observation period. The drug exposure date.
But you've got 12 months of prior records before the index event, right?
We will if the observation period start date starts longer than a year before the exposure date. Let's just draw a picture. So here is my observation period. Here is my drug event, okay? And let's say that this is the 365 days right here, okay? So what I'm saying is I have this event right here. It's the drug exposure. And this is the 365 days. Actually, this is...
You want to exclude it if they've had 365 days before.
No, I want to include them. Right, so this is a good point, right? So what we're saying is that the start date of this observation period has to be between all time, all right? So we're saying like go back all time, and we have this start date that's 100 and like that, this period, this time between here and here, we're saying has to be longer than 365 days. So the start date here has to be longer than 365 days away from this date. This picture sucks, I know, I'm sorry. So we're saying that the observation period start has to be starting longer than 365 days. If it does, then you're included because your event had more than 12 months of duration before. Is that all right? I know this is strange, and this is why it's so easy to just put it here and just avoid the whole thing. But the reason why I want to do this is because I would like to know how many people did have the 365 and how many people did not have the 365. I will be able to see how many people in my my list of drug exposures. How are we doing on this so far? Is this all right? Yeah. How about 5 more minutes and then we'll break for lunch? We'll do one more. So this covers the 12 months of prior records. This is just saying there was an observation period. The observation period started longer than 12 months before the exposure. Okay, let's make another one. Let's call this the age. Okay, so we're going to add a criteria, but this criteria is based on the person level, the person itself, not about the event, we're not looking for other events at this point. We're actually looking for some demographic information about the event, the date of the event. So we're going to add what's called demographic criteria. Demographic criteria lets you ask the question about how old were you, what year did the event start at, and it's like demographic information about the event from your initial event. So we can ask questions about what the age of this person is, what the gender is, that thing like that. We can do, using demographic criteria, we could say things like, has to be men and older than this age, or could be a woman and older than some separate age. You know, these type of criteria are to basically ask a question about what the state of the person was at the moment of the event. So we're saying that the age, they have to be, according to the paper, does anybody remember? Right. 22 and 99, something like that? 21? Okay, 99. Okay, done. What else did we say? They had to have no other anticoagulants, right? So we're looking for warfarin, but if they had dabigatran or one of the other drugs, like they shouldn't be in this cohort, right? So let's say no Let's just call it that. So I'm going to, where will I find other anticoagulant? What domain table? Right. I will set up a placeholder, but we're not going to go through the vocabulary searching because, as you saw, it's subject to network and other craziness. But I'm going to say these are my other okay? I'm not even going to put the codes in right now. They're not important. What's important is how the logic is using. So what are we saying about, what does that mean, no other anticoagulant? So we have a date of a first exposure of warfarin. What are we saying? They can stay if what? What is the logic of this statement? They can stay if what?
No more than 0 occurrence.
They have to have no more than 0, sure, or 0, right? You could say no at most 0, but let's say exactly 0 of whatever we're saying other anticoagulants is, and when are we going to look for that? All days before N. How about 1 day before? So in other words, the day of, you're taking an anticoagulant, so you disqualify yourself potentially if you had warfarin in the list of anticoagulants. Doing it this way means that, like, we can put an anticoagulant and we can include warfarin in that list, because warfarin, if you're looking for warfarin, you're not going to find a prior warfarin, so it's safe. But we can have this one anticoagulant list because we're going to need to use this cohort definition to define the first use of other drugs, like the other warfarin, the apixaban, right, all the other drugs. So what I'm doing is, this is the T definition, and I think somebody mentioned that. Wouldn't you want to basically apply that same rule to the other cohort? We are going to in 1 minute, so that we can get lunch. But so far, does this make sense? We're basically saying at the first moment of this exposure, they stay if they didn't have something else prior, a different anticoagulant sometime in the past. So you could have taken warfarin, and you could have taken drug A and drug B and drug C. We will let you in as long as you didn't take A, B, or C prior. But if you took A, B, C, and then warfarin, and your first exposure was warfarin, the fact that now we found, though, an A, B, C prior, you're out, because we're telling you you can't have another anticoagulant. That's an inclusion rule.
Actually says 365 days before, so you could be in the time of the observation period, you could have taken a pill, but then taken the anticoagulant, but it's been a year, and then you start again, and you could be entered into it.
So I think they did not say that in the paper. I think they said if you had prior anticoagulants ever, you're out. I don't think they said, I could be wrong, but I think. But if that, what?
They said in the last year.
All right, so then.
So you could have had a year and 1 day.
Told us to read the paper. Good job.
I think they're getting hungry. I think they're turning on me. So here we go. There you go. So we added it to the criteria. No other anticoagulants between the 365 day prior and the day before. All right, that good? All right.
So what happens if they start 2 drugs on the same day?
Good question, right? Right, so what did they say about that in the design?
Exit criteria. You add it to the cohort exit.
Okay, so they will exit when they take a drug on or after. Okay, yeah, we could do that. So talking about this, censoring events, they are going to get, because they did talk about exiting on a switch. So we would have to make a code list that has all the drugs that we consider a switch from. So this makes it a little bit more cumbersome to make the cohort definition, because one cohort definition is going to consider a switch. Like Riva switch means that you found a Dabi or warfarin or one of the other guys. But yeah, so centering events, it means exactly what it means. It's, we can add a drug exposure, and you say, like, you'd have to make a new code list specifically for this cohort definition to say, if I'm saying they started on warfarin, that needed a code list of those anticoagulants except warfarin, and that would be the switch. And then for the next one, I have to do it except Riva, except Dabi, except whatever. But I'm not going to go through that, but you're spot on. That's how we do it. To your question about the like having it on the same day, we could, there are Yes, so how about this? There is exactly one distinct drugs on, or like now we can say on. So if you did have two on the same day, this guy would be out because this guy can only have the exactly one. And in that case, we're throwing them out. Your censoring event would probably work as well because they will censor on the day they entered. But I'd have to look at the actual logic if that gives you a cohort. Yes. Wait, one other thing about this point though. We said drug exposure, so if they took a 5 milligram and a 10 milligram on the same day, that would be a problem. That would be two distinct different ingredients. So in order to get around that little wrinkle, which we've done, which we have had to do, talk in terms of drug errors then, because drug errors rolls it up so that when you're talking about distinct in a drug error, you're really talking about two different ingredients. So we would just say, okay, no problem. Oops, other anticoagulants in the drug error table, so we're only looking at ingredients. We better have exactly one on this day, looking between, 365 before and the day on. Okay, and then we can just get rid of this. There we go. At least one using distinct. Yep, good. Pardon? Exactly one? Exactly one. Thank you. We just did all this work to get rid of dupes, or more. Yes, there has to be exactly one distinct ingredient on that day. Then we know we didn't have two at the same day. But I know we got to have lunch, but just as a curiosity, because we face this all the time when we do these characterization, we'll find like, why are people showing up to have this other exposure that we, So what do you do in cases of? What do you guys think is the right decision when you have new user? And like it's the same day. What if you had both arms on the same day? Neither of them is the first. Like, do you just throw them out entirely? Throw them out entirely. Yeah, sure, why not? That seems to be reasonable. What would you say? Yeah, but what's funny about claims data is that things happen. Oh, you could rule them out as an error, probably an error in coding. We don't trust this record because whatever. That's a good point.
If you were just doing an analytical data set, you'd probably just create flags and then clean them up later.
So
because we're going to ultimately hand this off to do analysis, we need to define it now.
we got to define it now, right, exactly. All we're doing with cohort definitions is saying this is the time window to find those flagged elements in your observation data, right? So this is, again, basis. This is just the basis of it. Okay, I know we got to stop and get some lunch, but here we go. So I think other than the Townsend score criteria, which I don't even know if that was a criteria. They said they wanted to have it included in their covariate model, but I don't know if that necessarily ruled them out from being in the study. I don't know. I'd have to look at the paper again more closely. But right, the Townsend score is one of those things that we didn't have. But we could, in a deeper dive of cohort definition, we could look at to see what observations in data could we find to infer a Townsend score. But from what I know of the Townsend score, it was things.
So there's two approaches for a score, like Townsend score. If this was something that's in your data source and in your CDM as a measurement, then you could use one of the Atlas UI to go to the measurement domain, because Townsend score would be a measurement. It would be in the measurement table, and you can then filter and put your criteria on Townsend score. I don't even know what Townsend score is. Maybe some of you do. Anybody?
All right.
I looked in Wikipedia, something to do with if you're employed or not.
Oh, right.
Material deprivation kind of population, unemployed, non-car ownership, non-home ownership, or household income.
All right. Okay. So what we just described here, and then we can take a break, is a new user cohort. I also wanted to talk about, like, okay, well, we have our T, what about an O? And so we'll just do that briefly, but we also want to get to Juan's presentation and Joel's. So why don't we take a break, grab some lunch, and maybe we can start up just maybe 15 minutes early before 1 o'clock, and I can just run through the outcome, like what would an outcome look like, and then we can have some fun with the phenotyping. Probably.
So half an hour break.
Let's take a half-hour break. All right, everybody. So I just wanted to complete the new user cohort design real quick because there was one or two things left that we didn't talk about, and I think it's important to cover. So one of the things that they talked about in the paper was that you follow them, they are in the cohort as long as they're receiving continuous exposure to the drug in question. And they said things about if they stop taking it for 30 days, then they're out. So what I want to call attention to is, we're talking about cohort exit. So they started with their first exposure, they're in, and they will stay in as long as they are taking the drug without a break of 30 days. And Rima, I think you mentioned something about the continuous exposure of a drug. Okay, so this is, and you said in the drug era, it's hard coded to 30 days, and you're using. So in the cohort definition, by default, you have this end of continuous observation. So you start, and then you just stay in forever. There's other choices we talked about having a fixed date offset. So you could just say you're in the cohort for 30 days, and that's it. But we can also say continuous drug exposure. And to do this, you choose continuous drug exposure. You choose the code set that has the drug exposure concept IDs in them. So in this case, we're going to use warfarin. And you can specify how much time between the end of the exposure and the beginning of the next exposure can elapse before it should be considered a discontinuation of exposure. So if you think in terms of our diagram here, so if we had two exposures, oh well, man, it's all gone. If you have these two exposures, right like this, one of this guy and this guy. Okay. So in the data, there's these exposure records. This first setting about time between exposures is saying how much time can be elapsed between these two distinct exposure events to bring them together and just consider it, okay, keep going. So that if there was this one and then there was another one and another one, you'll keep on going as long as the gap between these exposures is maintained into a certain range. And so in the cohort definition, we could say, I don't know what it was, thought it was 30 days, like they would allow up to 30 days of gap. So that's just basically telling you how wide these individual exposures can be before they come together. A natural question would be, what if they started early? Do you kind of overlap and add the overlap to the end of the exposure so that if they really overlapped a lot, like let's say they had a 90-day exposure, but for some reason they started 7 days earlier, do you take that 7-day early time and add it? And the answer is no, it is not that sophisticated. It simply does what this diagram is showing as far as each individual exposure is carried along, and as long as that window is covering the distance between the end of the one exposure and the start of the next, it'll continue that exposure along. And then finally, when we have, just to bring all this back a little bit to make it a little bit more reasonable, let's say actually we get rid of this guy, and there was a large gap between that exposure and the other, then the cohort would start here and end here. That's what that is. But if this was actually brought together, can I do this? Yeah. So if it was more like this, and that was within the time window, now my start and end is like this. Okay, so that is using continuous drug exposure exit, cohort exit. Okay, that is found under this option, the event persistence, continuous exposure exit. Now,
continuous can be driven by claims, by actual document administration.
It's off of the records that are in the drug exposure table, and absolutely yes, it could be any of those things, as long as it's in the drug exposure table. Yes.
Just a quick question. So this is a drop down, the days that you choose to
Yep.
do the gap.
You can do any value.
Okay, so you can add any.
Yeah. Most people see that. It's like, oh, is this my only choices? No, you can do like 22.
Okay, so you can type on it.
Yeah, absolutely. And then, yes? It is absolutely an ad hoc creation of a drug error. Sometimes, let me just say, sometimes you'll get injectables that don't have good capture of like the injectable is the one day, but you know the treatment pattern of it is you come in every 3 weeks or every 6 weeks. So you could actually specify that you want the exposure to be like a fixed duration. And then, I'm getting off track a little bit, but yes, this is creating an ad hoc error that you can decide how long between the individual exposures, because drug error does it by default 30 days, but you may know better that the drugs in question are more like 60 days or 15 days, not the mercy of the ETL, right? And the last thing I'll add here about the setting is that you can also add a number of days after you get your whole range. You can also what's called the surveillance window. So after you've allowed the gap to chain things together, you can do a one-time, I want to add 30 days to the end of the exposure to represent like we want to consider them under the treatment of the drug even after the record ended. So if you don't want to do that, leave the 0. But if you did, you have the option. Yes? Yes.
Is it possible to also do the minimum?
And it's the definitely maximum length of the gap. It's not like you must see a gap of 3 days. That's an interesting point, but no.
If we added a minimum, Michael, we would have our tool for identifying treatment cycles.
Interesting. Okay, so that is the first thing I want to point out. Yes?
So in case there is overlap between the exposures,
Yes.
do you have a way to count that?
Nope, no, it's just, you're describing a way of dealing with stockpiling and things like that. It's simply start and end dates, and as long as the start and end is within a range, even if you started early, that would be like a negative 2 days if it was an overlap. As long as it was, it doesn't take that into account, so. The last thing that was described in the definition was that if you switch, then you are kicked out. So what I had to do, and I did it while we were on break, is I created a new concept set specifically for this cohort of switched anticoagulants. It is basically the list of all of the anticoagulants that we really care about, except the one that this cohort is responsible with, because we don't want to have it so that you take your first warfarin, and then if you see a warfarin again, you're out. So I had to make a special concept set that had all the other ones that would disqualify me from being continuously treated with warfarin. So that is done under the censoring event. So what that means is, if I have my diagram here, if this is the period of warfarin exposure, and then for some reason I saw an anticoagulant, say right here, then my time at risk would go, my cohort duration, because of the censoring event, would go from the start of that, and then it would be interrupted by that censor event. And we call it a censor event. There may be some opinions about that's not a censor event, but that's a censor event in Atlas. It's basically any observational event that you can identify that happens during your entry period that will automatically set your exit date. So using a combination of continuous exposure to find what the continuous exposure says my end is, and then using a drug exposure event to tell me, actually, you have an other anticoagulant that should end you. Using that combination of rules, that is what the result of this particular use case would be.
Can you generate one concept set from another? So could I take all anticoagulants and take away warfarin and exclude warfarin?
That you'd have to call that a separate concept set, but you could absolutely do that.
No, but could I physically include
Other concept sets and other concept sets? No, we don't have the capability to nest. Yeah. So I did do a generate. This keeps on coming up with 0. So again, this is SimPuff data. So there is, and that's some kind of output bug there. But with SimPuff data, I tried to make this show up records because it was, because we were, let me reload this.
I was surprised that UK report they could track the continuation of prescription medications. I would suspect in our databases that for one individual to track their drug usage, there's not enough shared record between pharmacies and doctors where you could be sure that somebody took it continuously.
So again, it comes down to what assumptions you're going to take from your underlying data source. If you don't feel that your data source supports that assumption, then your data source isn't appropriate. Oh, because we got 0 records? This is SimPuff. It's meaningless data. It's just synthetic data. It might not have any reflection in reality. So I wanted to actually run this on our own internal environment But that, unfortunately, was with the Wi-Fi getting out is challenging. So actually, I have two.
For drugs, can you do ORs or exclusive ORs on searches for those? Like you want to say you took warfarin or you took any of the others, or if you did an exclusive OR where they couldn't take two of them, they'd only be able to take one of those. Can you do ORs or exclusive ORs when you do searches for drugs?
Yes, but I have to right now. I'm having trouble thinking about what the Boolean logic would be. But yeah, I think an exclusive OR means like you took the one without the presence of the other, and I think you define that as two different cohorts, and one is exclusively A, and the other cohort is exclusively B, and A says you couldn't have B, and B says you couldn't have A. Is there something? And there isn't. And the reason why the thing you're describing is sort of like, well, this is the exclusive cohort. They either took one or the other, and it's not that sophisticated in a sense that you really have to spell out individually what you are looking for in the data, and that's just the way. Sure. Okay, so we want to get on to the next thing. I just wanted to cover the last two elements of the study design for the population, which was the event persistence and censoring events. And I breezed through that very quickly, but hopefully that comes across that we can define cohort exit as continuous exposure, and we can also terminate cohort entry by using these censor events. And if we find a censoring event within a time period, then that will create an exit date of the cohort. I did want to do just an example of an outcome cohort, but I think we're running short. Do we want to just try to do a quick outcome cohort real quick? All right. That's all right. So to do that, we'll just make a new cohort. How about we do the GI bleed? Now, what's interesting, normally in OHDSI things, if you had the prior outcome, it's kind of like if you had it before, you'll get it again. So whenever we try to do outcome cohorts from most of the OHDSI studies I've been, although I can speak from personal experience, usually I'll make a cohort of the first outcome per person, and you are disqualified from being included in the calculation of an incidence rate, for example, if you already had the outcome prior. So you're kind of like, it's not an exclusion rule of the cohort, it's just you're disqualified from being counted in the incidence rate calculation, for example, because we've identified you've already had the prior outcome. But in this study, they said that you can actually have the prior outcome. I believe they said that you can have suffered a GI bleed in the past, but that's fine, you're still in, and we'll let that happen, and then we'll look for new GI bleeds in the future. So the thing about these outcome cohorts is that we're not going to refer to either T or C's cohort when we define our outcome. So what we really need in our outcome cohorts is incidence events of a GI bleed. So this is how we would do that. We're going to make our GI bleeds come from conditions, very basically come from condition. You could say that a GI bleed isn't a GI bleed unless they did some surgery or something, which would make it a more robust cohort definition, but I'm going to keep it simple. So we are having any condition. We're going to make a new concept set. Just going to click through this, and this is GI bleeds. I'm not going to worry about creating the code list right now. This is just logically, this is what we're going to do. Okay, now, for an outcome cohort, do we really need to know that we are saying that it doesn't matter if it was the first GI bleed or not? So having prior observation to these outcomes doesn't matter, right? We're just going to take, if you got it, we want to record it. We're not going to say, oh, you had to have a year of prior observation. We're not going to do that for this outcome. We're just going to say you had a GI bleed. Now, we don't want to limit this to the one earliest event per person because we want to see GI bleeds occur multiple times per person. So saying earliest GI bleed is not what we want to do for this cohort. We want to say all GI bleeds for the person. Do we have any inclusion rules? Probably not. We could have inclusion rules for the outcome if we wanted to be more specific about what the outcome truly was, the outcome, if we wanted to try to avoid false positives on the outcome, which is admittedly very important for if you're going to do a study and you're looking for the outcome, you want to make sure you're defining it robustly. But for this purpose, let's just say just the code of GI bleed is enough. Actually, why don't we say that it had to be in an inpatient setting? So I'm going to add a visit, and I'm going to search for I don't know if we're seeing a delay in the data in the query. Okay. So we have an inpatient visit, maybe an emergency room visit. Sounds good. Okay. So I actually kind of made it a little bit more sophisticated. It's not just the code anymore. I basically said that the setting of the code had to be an inpatient. Perfect. Don't really care about inclusion rules for here. Now, in order to make this incidences of like a new, like an occurrence of the GI bleed, I don't want to take events and leave people in the cohort for the entire time, right? Otherwise, it would be you're having a GI bleed from the first time you had it till the end of your observation, and you're not in a state of GI bleed for that long. So what do you think? If we wanted to say from the event of the GI bleed, how long do you think between one coding of a GI bleed to a subsequent coding of a GI bleed, like how long do you think a GI bleed should persist? You want to say just a day? 2 days? Maybe 1 or 2 days? We don't have to think too hard on this. It's just, the point is it's not months, right? So we could, right, they could have another one, right. So we could say our inclusion event is not the coding of a GI bleed, like a diagnosis of a GI bleed. We could actually say our events are visits that have a GI bleed within the same visit. Like that could be it. So if they actually had multiple GI codes, that visit will only come up the one time because it's just the one event. So that is definitely an idea. But let's just do it like this, just to see how that would work. How about we say that a fixed duration, so we have our GI bleed code, and let's just say I'm going to make it a single day event. Like you had your GI bleed, it's a single event. It might have multiple times. Now, we're going to lever, so now I have, if you think about a timeline, here's my observation period, and I have like little blips of GI bleeds potentially for a person, just like short little intervals of GI bleeds. How many days should pass before a single blip of a GI bleed is considered a distinct GI bleed event? Just as a general logical problem, like what do you think? Like if 15 days. All right, so what we will do is we will make this cohort era gap size for 15 days. And what that will do is that we'll have our timeline of those individual events. That was our cohort entries, right? And we said they're only going to be in it for 1 day. However, because I specified a 15-day gap size, if I see that 1 day event, 7 days, 1 day event, 7 days, 1 day event, those three guys are going to be chained together because they happened within their 15-day separation. So you'll have this cohort era of in that case, 21-day episode of you are undergoing a GI bleed. And then 2 years later, another one can appear. And maybe a couple of those guys will get chained together. And then 2 years later. And this is what this paper wants. This paper wants you to basically identify those moments that you had the GI bleed so that even if you had it before starting taking warfarin, we're only going to look for these outcomes in the study after your cohort entry for that target. Okay? And in fact, they're only going to look for those outcome events during exposure in the cohort. So in other words, it's not enough that you had the outcome after the treatment initiated. It had to be while you were being treated, which is why we made our target cohort at the continuous drug exposure that establishes our window that we are going to look for outcomes. If you had the GI bleed 3 years after you stopped taking the drug, you're not going to be counted as an outcome, right? We're just talking about how the study would be performed. So just in closing, this right here, which is kind of simple, establishes our cohort of GI bleeds. And we can, with the treatment cohort and the outcome cohort, we can now calculate an incidence rate. Give me all the people that initiated treatment, find me all the people that had a GI bleed, and look for the people while on treatment that they actually they entered the outcome cohort. If they happened to do that during their period, then it's an incidence of it's like a case of an outcome. Yes.
So where does that intersection, where do you actually do that intersection?
So there's this incidence rate tool where you can create a new analysis and you specify what your new users of warfarin, and then you add your outcome of your GI bleeds. And so this is jumping ahead to application of the cohorts, but it's a very important question. Like, that's the question, like, where does this all come into play? What this is basically saying is, for each person, start with their cohort entry, calculate the amount of time it was between either the end of their cohort period, or, if you find the outcome, just up to the outcome. That's what the paper meant by, we follow them until either their end of their record, or they stopped treatment, or they had the outcome. They're kind of covering all these different reasons to stop following the people, but what this tool does is it takes two separate cohorts, the cohort of the treatments, cohort of the outcomes, and just calculates the time, and the number of cases divided by your total time is your incidence rate. It would work out to like one case in 200,000 years or something, whatever that thing was. All right, so we will definitely talk about that in the afternoon, but I wanted to just answer that question about how does that work. Okay, so.
Just a quick
Yeah.
question.
Oh, yes, go.
So when you have the outcome cohort, where do you define, like the outcome starts as of the time, after the 12 months of the 12-month grace period. So then you start looking for the outcome after that.
So what you're kind of on it. So you start looking for the outcome. You're looking for the outcome during the treatment periods per person.
Right. Where is that being defined?
That is just, that's not being defined here at all. All this is doing is it's establishing the periods of time that you fit the phenotype of GI bleeding. So that's all that's happening here. Using that information of these are the moments in time that a certain person has a GI bleed phenotype, we can now look at the treatment and say, did that person appear while on treatment in the T, in the cohort? And if they did, they are a case. And the time to event was whatever the time from their start of treatment to the start of their cohort, their outcome cohort date. So what that means is I can use one cohort and have, here's my GI bleed outcome. He wasn't in it. Here's my, the other ones. Cerebral hemorrhage. That was actually in it. So you use the same time window to establish everybody has the same time at risk, but what the outcome will govern what the effect estimate is of the certain drug. Is this outcome happening more likely in the population of the T or the more likely in the population of the C? But that's about the comparative effectiveness stuff. But in all cases, it's always about your T is an independent period of time. Your O is an independent period of time. When you want to look for an outcome amongst a population, you're just basically saying, did they enter an outcome cohort while being inside their target cohort? That makes them a case. That's what a case is. So far, so good with that? Yes.
One question. So when you execute the circle in the backend, you do first look at two independent cohort and do the overlapping, right?
Say again.
So when you execute the circle in the backend, right?
What circle or?
SQL.
Oh, sorry. Apologies. Yeah.
So you do first extract two independent cohort and do the intersection, right?
That would be. It wouldn't be really done on SQL to be actually technically accurate. You generate the cohorts in SQL, true, it's on the back end, but when you want to do that survival analysis, it's like gets pulled, all the peoples and their dates get pulled into like an R session, and then it compares the dates. And to be honest, actually, with incidence rates, we do that in SQL. It is totally a doable in SQL operation.
Well, what I mean is it the most efficient way to do this? Because you are going to pull out two huge cohorts.
Oh, I see. Is it, I see, from a performance perspective or just efficiency, isn't it more efficient to basically confine it to like an overlap? I guess yes, but you get more flexibility if you don't constrain yourself in that way. So that is the trade-off. I'm sorry, I misinterpreted your question, but yes, absolutely. Yeah. And that's getting back to that whole thing about you don't define your T's in context of the O, even though you could try to think how to phrase that. I guess really the bottom line is that these are very independent entities. The T's and the O's and the comparators, they are generated independently. Yes, it's absolutely true that when I generate my outcome cohort for like something that's kind of common, yeah, I could have 5 million people in that cohort and only 200 people in my T. That's okay. I know it doesn't sound efficient, but it's okay. We need to know all the people that possibly could appear in a cohort, and then you just look for these amongst these 200 people, did any of these 5 million people, or any of these guys during that period? It's just kind of you have to do it.
Yeah, but in that scenario, if 5 million people in outcome cohort, we can supply the index date, like the period based on our target cohort to define to shrink the size of our outcome cohort, right?
Yes, you could say that. Yeah, you could do that. You could do that. In practice, we don't. In practice, we're fine. In practice, there's 5 million people with their times. There's 200,000 people with these times. It's just a sequel. I understand what you're saying, but we don't bother with that optimization. It's just not done. So
something doesn't become a cohort doesn't become an outcome cohort until you put it in the context of the system, right?
Exactly.
So you basically you could switch them completely around and you could make.
You could say, what's the incidence of starting treatment based on the first diagnosis? That's technically an outcome. But the outcome is an outcome because you're looking for it amongst a target population. A cohort could be served as an outcome or a target. It is absolutely true. In both cases, it's just a bunch of people with start and end dates. But I think, though, sometimes when you know your cohort is going to be used as an outcome, you make certain, you are less stringent about prior observation time, for example. So when I made that outcome cohort, I said I don't care about prior observation because that wasn't a consideration when initiating treatment. With the outcome, I actually want to know every possible incidence of it. So it's not quite fair to say you totally don't care if it's an outcome when you define your cohort. You kind of do, but only in the context of, because I want this to be all cases of GI bleeds, I do not care about prior observation. As soon as it happens, I want to know about it. I don't care about having 12 months of prior observation. You're going to use it as an outcome, so you don't look for that type of, you aren't that constrained. So this is a long way to say that you do think about how the cohort will be used when designing it.
Structure cohort a little bit differently, but
yep.
Then you don't doesn't it ask you, well, is this an outcome cohort or this is not?
Right, exactly. Okay, so that's it.